What if the glaciers that buried continents were not summoned by accident, but by design? What if someone, somewhere, once looked at a warming world and chose winter forever? Wherever you are tonight, curled beneath blankets, watching stars through glass, or lying in the half-light between waking and dreaming, I'm glad you're here. This is a story about ice and memory, about the possibility that what we call natural might have been, once, a careful choice, about the idea that intelligence older than our species might have left fingerprints not in monuments, but in frost. Let the weight of the day fall away. Let your breathing slow like glaciers forming. Because tonight, we're going to trace the edges of an impossible question, not to answer it, but to let it settle like snow. There was a moment, though moment is the wrong word, for it lasted 20,000 years, when Earth began to forget warmth. It happened slowly, the way night falls in the Arctic, where the sun doesn't set, but simply lowers and lowers until one realizes it has been dark for months. The planet had been warm. Not hot, not tropical everywhere, but temperate, comfortable. The kind of world where forests breathed across latitudes and ice was a curiosity that lived only at the poles, contained, polite, seasonal. And then the ice came. It didn't announce itself. There were no warnings written in stone, no prophets who saw the glaciers forming and fled south. It simply began. Snow fell in regions where snow had always melted. But this time it stayed. The next year, more snow fell on top of the old snow. Then more. Each winter added a layer, compacting the layers beneath, squeezing air from the spaces between crystals until what remained was not snow at all but ice. Dense, blue, ancient even as it formed. Within a few thousand years, sheets of ice 2 miles thick covered what is now Canada, Scandinavia, Siberia. Places that had known oak and deer and the sound of rainfall became tombs of frozen silence. Scientists call this the Pleistocene glaciation. They speak of it in terms of orbital mechanics, of wobbles in Earth's axis and variations in solar radiation. They point to something called Milankovitch cycles, the slow, predictable dances Earth performs as it circles the sun, tilting and swaying in patterns that stretch across tens of thousands of years. And yes, these cycles are real. The mathematics is sound. The ice ages correlate, more or less, with these astronomical rhythms. But more or less is not the same as exactly. There is something in the timing that doesn't quite fit. Something in the speed. Ice ages are supposed to creep into existence, gradual as erosion, taking tens of thousands of years to establish their grip. But the geological record shows something different. It shows ice forming in what amounts to a geological eye blink. Glaciers advancing at rates that seem less like natural accumulation and more like deployment. Deep in the ice cores pulled from Antarctica and Greenland, scientists have found the memory of this transition preserved in frozen time. Each layer of ice is a year. Each bubble of air trapped within is a breath the atmosphere took centuries ago. By drilling down through miles of accumulated ice, researchers have extracted cylinders of frozen history that span hundreds of thousands of years. They slice these cores into sections, measure the ratios of oxygen isotopes, analyze the dust particles, count the carbon molecules. They are reading the diary of the planet. And what that diary says is strange. The transition into the last ice age, the one that ended only 12,000 years ago, the one our ancestors witnessed, shows a temperature drop that occurred not over millennia, but over decades. Perhaps less. Tree ring data from fossils preserved in bogs suggests that within a single human lifetime, the climate shifted from temperate to glacial. Rivers that had flowed for 10,000 summers froze solid and stayed frozen for 100 centuries. Animals that had evolved over millions of years to thrive in woodlands and grasslands suddenly found themselves wandering through tundra, through landscapes of ice and wind where nothing grew but lichen and desperation. Most of them died. The megafauna, mammoths, mastodons, giant ground sloths, saber-toothed cats, dire wolves, are often thought to have been hunted to extinction by early humans. But the timeline is more complicated than that. The die-offs correlate precisely with the ice. They happen in waves that match the glacial advances, as if something was clearing the board, as if the planet was being prepared. But prepared for what? There is a theory, rarely spoken in academic circles, but whispered about in late-night research sessions, that Earth's climate is not as stable as we assume. That the warm periods we call interglacials, like the one we're living in now, are actually the anomaly. That ice is Earth's default state, and warmth is the exception. That for the last 2.5 million years, the planet has been locked in a pattern of freeze and thaw, with the frozen periods lasting roughly 90% of the time. We are, right now, living in a brief window of mercy between walls of ice. But why does the ice come so suddenly? Why does it stay so long? And why, when it finally retreats, does it do so with the same abrupt speed, melting in pulses, flooding coastlines overnight, drowning forests and valleys, and the campsites of early humans who woke one morning to find the world they knew submerged beneath meltwater? Natural systems don't typically behave this way. They tend toward equilibrium. They shift gradually, with feedback loops that dampen extreme changes. A planet warming too quickly will generate clouds that reflect sunlight, cooling itself. A planet cooling too quickly will reduce ice coverage, exposing darker ground that absorbs more heat, warming itself. These are the thermostats of Earth, the automatic systems that have kept the planet habitable for billions of years despite asteroids, supervolcanoes, and the slowly brightening sun. But during the Pleistocene, these thermostats seem to have been overridden. The ice came anyway. It stayed anyway. And the planet's normal regulatory mechanisms, the ones that should have kicked in, that should have stopped the glaciers before they buried entire continents, simply didn't. Unless they were prevented from doing so. Unless something wanted the ice. This is not a mainstream scientific position. It exists in the margins of peer-reviewed papers, in the anomalies that don't get mentioned at conferences, in the data points that are labeled unexplained and then quietly set aside. Because to pursue this line of thinking requires asking questions that science is not comfortable with. Questions about intention, about design, about the possibility that Earth's climate history might contain fingerprints that are not random. And if there are fingerprints, then there must have been hands. But whose? The glaciers don't answer. They only preserve. Locked within their layers are ash from volcanic eruptions, dust from distant deserts, pollen from plants that no longer exist. Each element tells part of the story, but the story they tell is incomplete. It's as if chapters are missing, as if someone edited the manuscript before it was frozen into permanence. There is a lake in Antarctica buried beneath 2 miles of ice that has been sealed away from the surface world for 15 million years. Scientists call it Lake Vostok. It is larger than Lake Ontario, hidden in darkness and pressure, a pocket of liquid water that exists because the weight of the ice above generates just enough heat through compression to keep it from freezing. When researchers finally drilled down to it, carefully, slowly, terrified of contaminating this pristine time capsule, they found water that had been isolated since before the Ice Age began. They found life. Not complex life. Not fish or plants. But bacteria. Microorganisms that had been evolving in total darkness, in complete isolation, for millions of years. Species that exist nowhere else on Earth. A separate branch of evolution, hidden beneath the ice like a secret the planet kept from itself. But they also found something else in the waters of Lake Vostok. Something the researchers mentioned once in preliminary reports, and then stopped talking about. Magnetic anomalies. Structures on the lake bed that don't match any known geological formation. Geometric patterns in the sediment that radar imaging picked up but couldn't explain. The official statement was that the anomalies were probably just unusual rock formations, distorted by the immense pressure and the limitations of ground-penetrating radar. The data was inconclusive. More research was needed. And then the research stopped. Funding dried up. The international agreement governing Antarctic exploration became stricter. Lake Vostok was quietly removed from most active research agendas. This happens more often than one might think. Not cover-ups, exactly, but strategic silence. When discoveries don't fit existing frameworks, when they raise more questions than they answer, they are often simply not pursued. Not because of conspiracy, but because of inertia. Because science operates on consensus, and consensus requires reproducible results, and some things buried under 2 miles of ice are difficult to reproduce. But the whispers remain. Whispers about other lakes beneath the ice. About radar surveys that show linear features too straight to be natural. About magnetic signatures that suggest metal, or something like metal, in places where no metal should be. About drill cores that brought up samples containing elements in ratios that don't match any known terrestrial source. These are not proven facts. They are hints, shadows, the kind of evidence that lives in footnotes and gets labeled pending further analysis. But when enough shadows accumulate, they begin to suggest a shape. And the shape they suggest is this. Something happened during the Pleistocene that we don't understand. Something that involved not just ice, but intention. Consider the timing. The ice ages began roughly 2.5 million years ago, right around the time that a particular branch of primates, our ancestors, started to show signs of increased intelligence. Stone tools appear in the archaeological record. Fire gets domesticated. Language, we assume, begins to develop, though language leaves no fossils. It's as if the planet waited for something to evolve before initiating the freeze. Or perhaps it's the reverse. Perhaps the freeze was initiated to force evolution, to create pressure, to select for intelligence, adaptability, problem-solving ability. Ice is the ultimate test. It forces cooperation, innovation, planning. Species that can adapt die out. Species that can adapt become something new. Humans evolved during the ice ages. We became what we are in the margins between glaciers, in the brief warm periods when the ice retreated just enough to allow forests to return, game to flourish, tribes to grow. And then the ice would come back, and we would be pushed south again, squeezed into refugia, forced to compete and collaborate and invent new ways to survive. We think of evolution as random, as mutation and selection acting without purpose, simply filtering what works from what doesn't. But what if the filter itself was designed? What if the pressure that shaped us was deliberately applied? This is not a comfortable thought. It suggests that humanity is not the product of blind chance, but of some kind of cultivation. That we were grown, the way one might grow a particular strain of wheat or breed dogs for specific traits. That the ice ages were not climate accidents, but a breeding program spanning millions of years. For what purpose? The ice doesn't say. It only remembers cold. It only preserves the thin layers of ash and dust and trapped air that mark the years of its dominion. But within those layers, if one knows how to read them, there are patterns. Cycles within cycles. Periodicities that align with astronomical phenomena, but also with something else. Something that leaves traces in isotope ratios and magnetic field variations and the distribution of rare earth elements in sediment layers. Something that looks, to those few researchers willing to see it, like a signal. Not a message. A signal is different. A message contains information, meaning, intent spelled out. A signal is just a pattern, a regularity. a sign that something non-random occurred. And buried in the ice core data, in the layered history of Earth's frozen memory, there is a regularity that should not exist. A pattern in the timing of glacial advances that correlates with nothing natural. Nothing orbital, nothing solar, nothing geological. It correlates with something that has not yet been named. But what the planet buried, it never truly forgot. The ice remembers. And as we drill deeper into its layers, as we extract older and older samples from the frozen archive, we are beginning to remember too. There is a moment in every ice core analysis when the scientists reach a layer they call the transition zone. It's the boundary between one climate state and another, between warm and cold, between forest and tundra, between the world that was and the world that came after. In a natural transition, this boundary should be blurred, gradual, a mixing of signals as temperatures slowly shift over thousands of years, like watercolors bleeding into each other on wet paper. But that's not what the cores show. Instead, the transition is sharp. A line. On one side, pollen from temperate trees, oak, elm, pine. Dust particles that traveled on warm winds from distant grasslands. Air bubbles with higher concentrations of methane, the signature of wetlands and life. And then, within the space of a few centimeters, representing perhaps a decade, maybe less, everything changes. The pollen disappears. The dust becomes different, finer, carried on colder winds from newly exposed rock. The methane drops. The oxygen isotopes shift in ratios that indicate a temperature plunge of 15 to 20 degrees Celsius. Not over centuries, over years. This is called the Younger Dryas event, and it happened 12,800 years ago. Earth was warming, emerging from the depths of the last ice age. The glaciers were retreating, and then, suddenly, they stopped retreating and surged forward again. Winter returned for another 1,000 years. A final pulse of cold before the ice finally released its grip. No one knows why. The theories are numerous. A meteor impact, a volcanic eruption, a sudden drainage of glacial meltwater that disrupted ocean currents. Each explanation has evidence supporting it and evidence contradicting it. Each fails to fully account for the speed, the totality, the precision of the cooling. But there is one piece of evidence that rarely gets discussed outside specialist circles. During the Younger Dryas cold snap, while the northern hemisphere was plunged back into ice age conditions, the southern hemisphere barely noticed. Antarctica's ice cores show almost no temperature change during this period. It's as if the cold was targeted, focused, applied to one half of the planet while the other half continued its slow warming trend. Natural climate phenomena don't typically work that way. When Earth's orbital parameters change, they affect the whole planet. When volcanic eruptions inject ash into the stratosphere, the cooling is global. When ocean currents shift, both hemispheres feel the effects within decades. But the Younger Dryas was different. It was hemispherical, selective, almost surgical. And when it ended the same way it began, abruptly, within a span of years so short that trees preserved in bogs show the transition in their growth rings. One ring, Ice Age. Next ring, warmth. As if someone flipped a switch. The botanists who study these tree rings don't use words like engineered or deliberate. They use words like anomalous and unprecedented and requiring further study. But in the spaces between their carefully neutral language, a question hovers. What if the ice was never natural to begin with? What if Earth's climate, for the past 2.5 million years, has been operating under parameters that were set rather than evolved? What if the glaciers came because something summoned them, and stayed because something maintained them, and retreated only when whatever controlled them allowed the retreat? This would mean that the planet we think we know, the stable, self-regulating Earth that science describes, is actually a managed system. A garden, perhaps, or a laboratory. A place where conditions are adjusted according to designs we cannot see, for purposes we cannot fathom. It would mean that the ice ages were not catastrophes, but corrections, not accidents, but interventions. And if that is true, then every assumption we make about our place in the world, about the naturalness of our evolution, about the randomness of our existence, would need to be reconsidered. We would be living not on a planet, but in a terrarium, not products of chance, but specimens under observation. The ice cores don't confirm this. They only hint. They whisper in languages of isotopes and dust particles, in patterns that emerge only when decades of data are compiled and compared. They speak of regularities that should not exist and transitions that happen too quickly to be explained by the slow grinding of natural forces. They speak of something watching, something that knew how to change a planet's climate, something that understood atmospheric chemistry, orbital mechanics, ocean circulation patterns, something that could calculate how much ice was needed, where it should form, how long it should last, something that could engineer winter. And somewhere in the frozen archives of Antarctica, in layers of ice that have not yet been drilled, that have not yet been analyzed, there may be evidence that would prove this beyond doubt, or disprove it entirely. But those layers remain locked beneath miles of glacial weight, waiting, preserving their secrets until the day when humanity develops the technology, the courage, or the permission to look. Until then, we are left with questions, with the strange precision of glacial advances, with the impossible speed of climate transitions, with the feeling, impossible to quantify but difficult to dismiss, that the ice ages were too perfect, too timed, too effective at shaping the evolution of intelligence on this planet to have been entirely accidental. The glaciers remember something we have forgotten, and as they melt, as they retreat in our current warming world, they are releasing that memory back into the water, back into the air, back into the sediment layers where future researchers will find it and wonder what it means. But numbers do not lie, even when they whisper. And the mathematics of Earth's orbital cycles, the rhythms that supposedly explain the ice ages, contain within them a small but persistent error, a deviation, a variable that refuses to balance. Some truths are not lost. They are simply folded beneath silence, waiting for the equation that will finally make them visible. There are numbers that describe the movement of planets, equations that predict the dance of celestial bodies with such precision that astronomers can tell you where Mars will be 10,000 years from now, or where it was 10,000 years ago. The mathematics of orbital mechanics is ancient, elegant, and merciless in its accuracy. It does not approximate. It does not guess. It calculates. And according to these calculations, the ice ages should not have happened the way they did. A Serbian mathematician named Milutin Milankovic spent decades in the early 20th century working out the astronomical theory of climate change. He understood that Earth's relationship with the sun is not fixed. The planet wobbles as it spins, like a top losing momentum. Its axis tilts back and forth over the course of 41,000 years, changing the angle at which sunlight strikes the poles. The shape of Earth's orbit around the sun stretches and compresses on a cycle of 100,000 years, making summers sometimes closer to the sun, sometimes farther away. And the axis itself traces a slow circle in space, a precession that takes 26,000 years to complete, determining which hemisphere faces the sun during which season. These are the Milankovitch cycles. 3 different rhythms, 3 different timescales, all overlapping and interfering with each other like waves in a pond. When they align in certain ways, they reduce the amount of summer sunlight reaching the high northern latitudes. Snow that falls in winter doesn't fully melt in summer. It accumulates. Year after year, it builds. Ice sheets form. Glaciers advance. An ice age begins. When the cycles align differently, summer sunlight increases. The ice melts. The glaciers retreat. Warmth returns. Milankovitch published his theory in 1941, in the middle of a world war, and it was largely ignored for decades. But eventually, when ice cores and deep-sea sediment cores became available, when scientists could actually measure the climate of the past with precision, they found that Milankovitch was right. The ice ages did correlate with orbital cycles. The timing matched. The 100,000-year rhythm of glacial and interglacial periods lined up almost perfectly with the changes in Earth's orbit. Almost. But almost is where the mystery lives. The 100,000-year cycle is the dominant rhythm in the Ice Age pattern. It's the strongest signal in the climate data. Every 100,000 years, more or less, the glaciers advance and retreat. This should correspond to the eccentricity cycle, the stretching and compressing of Earth's orbit. And it does, roughly. But the eccentricity cycle is actually the weakest of the three Milankovitch cycles in terms of its effect on solar radiation. It changes the amount of sunlight Earth receives by less than 1%. The axial tilt cycle and the precession cycle both have stronger effects on seasonal sunlight distribution. Yet it's the weak cycle that dominates the Ice Age pattern. This is called the 100,000-year problem, and it has puzzled climate scientists for half a century. Why should the smallest orbital effect produce the largest climate response? It's like tapping a wine glass gently with a fingernail and having it shatter, while hitting it with a spoon produces only a soft ring. The proportions are wrong. The physics doesn't balance. Various explanations have been proposed. Perhaps Earth's climate system has internal feedback mechanisms that amplify the eccentricity cycle. Perhaps ice sheets, once they reach a certain size, become unstable and collapse regardless of orbital forcing. Perhaps there are nonlinear interactions between ice, ocean, and atmosphere that create tipping points and threshold effects. All of these may be true, but none of them fully explain the precision of the timing, the regularity, the way the ice ages start and stop almost on schedule, as if following a metronome buried somewhere deep in the planet's memory. There is a graph that climate scientists study. It shows temperature over the past 800,000 years, reconstructed from ice cores. The line rises and falls in a pattern so regular it looks almost artificial, like a heartbeat on a medical monitor, like waves on an oscilloscope. Every 100,000 years, the temperature drops into glacial conditions and stays there for 90,000 years. Then, abruptly, it rises. A spike of warmth lasting 10 to 15,000 years. Then it drops again. The pattern repeats. Over and over. 8 cycles in 800,000 years. The regularity is what disturbs those who look at it closely. Natural systems are rarely this regular. Weather is chaotic. Ocean currents shift unpredictably. Volcanic eruptions happen at random intervals. Even orbital mechanics, while mathematically precise, produce complex interference patterns when multiple cycles overlap. The combined effect should be messy, irregular, full of variation. But the Ice Age cycle is clean. Too clean. Each glacial period lasts roughly the same length of time. Each interglacial period, the warm breaks between ice ages, lasts roughly the same length of time. The transitions happen at approximately the same speed. It's as if Earth's climate is following a program, a schedule, a pattern that was established long ago and has been running ever since, with only minor variations. And within this pattern, there are smaller patterns, fluctuations that occur on thousand-year timescales, embedded within the larger cycles like fractals within fractals. The Dansgaard-Oeschger events, named after the scientists who discovered them, are sudden warming spikes that appear throughout glacial periods. The temperature rises by 10 or 15 degrees in a matter of decades, stays warm for a few centuries, then drops again just as quickly. These events happen roughly every 1,500 years during ice ages. Not exactly 1,500 years. The interval varies by a few centuries either way. But the periodicity is there, persistent, undeniable. No one knows what causes them. The proposed mechanisms involve ocean circulation, specifically the Atlantic meridional overturning circulation, the system of currents that carries warm water north and cold water south, redistributing heat around the planet. When this circulation weakens or shifts, it could trigger rapid climate changes in the North Atlantic region. This explanation is plausible. It fits some of the data, but it doesn't explain the regularity. Ocean currents are influenced by countless factors: wind patterns, ice melt, salinity changes, atmospheric pressure systems. These factors are chaotic, variable, unpredictable on timescales longer than a few decades. They should produce irregular fluctuations, not a pattern that repeats every 1,500 years for tens of thousands of years. Unless something is pacing the ocean, nudging it, maintaining the rhythm. And then there is the devil's staircase. This is what scientists call the pattern of temperature change during glacial terminations, the transitions from ice age to interglacial. Instead of a smooth, warming curve, the temperature rises in discrete steps, plateaus. The graph literally looks like a staircase, a period of rapid warming, then a plateau where temperature stays stable for centuries, then another period of rapid warming, another plateau, and so on, until the ice age is fully ended and the interglacial established. This pattern appears in every glacial termination in the ice core record. The same step structure, the same approximate duration for each step. As if the planet is following a protocol. As if the warming is being managed in stages, with pauses built in to allow systems to stabilize before the next phase begins. Natural warming should not work this way. When ice sheets melt, they should melt continuously as long as temperatures stay above freezing and sunlight remains strong. There is no reason for the melting to pause, for the temperature to plateau for centuries before resuming its rise. No known feedback mechanism produces this stepped pattern. Yet there it is, in every termination. For the past 800,000 years, orchestrated mysterious narrative while substantiating unnatural ice age theories, that I'm maintaining the mysterious, sleep-inducing tone while building the case for something unnatural about the ice age patterns. I need to continue exploring the mathematical anomalies and building toward the suggestion that these patterns might indicate deliberate engineering. The word count for this part is around 700 words, so I need to continue to meet my minimum. Some researchers have suggested that the steps correspond to the disintegration of different ice sheets. First, the Laurentide ice sheet over North America begins to collapse, raising sea levels and triggering a warming pulse. Then the process pauses while the system adjusts. Then the Fennoscandian ice sheet over Northern Europe collapses, triggering another warming pulse. And so on. This may be part of the explanation, but it still doesn't account for the precision. The regularity across multiple terminations separated by hundreds of thousands of years. Ice sheets are not identical from one glacial period to the next. They form over different bedrock, under different atmospheric conditions, with different internal structures. Yet they seem to disintegrate following the same script, producing the same step pattern every time. It's as if the ice knows when to melt, as if it's waiting for permission. And buried within the mathematical models that scientists use to simulate ice age cycles, there is a variable that no one talks about. A parameter that has to be adjusted by hand to make the models match the observed data. It's called the threshold value, the critical temperature or ice volume at which the glacial cycle transitions from one state to another. In theory, this threshold should emerge naturally from the physics of ice, ocean, and atmosphere. The equations should predict it, but they don't. Instead, researchers have to tune the threshold value to fit the data. They adjust it until the model output matches the ice core record. Different models use different threshold values. There is no consensus on what the correct value should be, or even what physical process determines it. This is not unusual in climate science. Complex systems often contain parameters that must be empirically determined rather than derived from first principles. But the threshold value is not a small adjustment. It's the difference between a model that produces regular ice age cycles and a model that produces chaos. It's the linchpin, the control switch, and the fact that it must be manually set, that it cannot be calculated from the physics alone, suggests that something is missing from our understanding. Some factor that influences the ice age cycle but is not accounted for in the equations. Some variable that exists outside the known parameters of orbital mechanics, atmospheric chemistry, and glacial dynamics. A variable that would only make sense if the ice ages were not entirely natural, if they were guided. If somewhere in the system, there is an input that science has not yet identified because science is not looking for inputs that imply intention. The mathematics doesn't lie, but it can only describe what it is given. And if the data contains signals of deliberate engineering, the equations will dutifully reproduce those signals without understanding what they represent. The models will match the observations. The simulations will predict the past. But the underlying question, why the pattern exists in the first place, will remain unanswered. Because the equations cannot ask why. They can only ask how. And the answer to how is written in the ice, in the step terminations, in the Dansgaard-Oeschger cycles, in the 100,000-year rhythm that matches the weakest orbital forcing, in the precision that should not exist in a chaotic system. The answer is there, encoded in patterns that repeat too regularly to be accidental, that correlate too precisely with cycles that should not dominate, that transition too quickly to be explained by the slow grinding of natural forces. But to see the answer, one must be willing to consider that the numbers are describing not just climate, but design. Not just physics, but purpose. Not just the behavior of ice and atmosphere, but the fingerprints of something that knew how to shape them. And that consideration requires stepping outside the boundaries of what science allows itself to think. It requires asking questions that have no place in peer-reviewed journals. Questions about who, not what. About why, not how. Questions that the mathematics whispers but cannot speak aloud. There is a frequency buried in the data. Not a sound, but a periodicity. A rhythm that appears when climate records are subjected to spectral analysis. A mathematical technique that decomposes complex signals into their component frequencies, the way a prism splits white light into colors. When scientists run spectral analysis on ice core temperature records, they find the expected peaks. The 100,000-year cycle, the 41,000-year tilt cycle, the 23,000-year precession cycle. These are the Milankovitch frequencies, the orbital rhythms that should be driving the ice ages. But they also find other frequencies, smaller peaks in the spectrum, periodicities of 8,000 years, 5,000 years, 2,000 years. Some of these can be explained by harmonics, mathematical artifacts created when the main cycles interact and interfere with each other. When you combine waves of different frequencies, you create new apparent frequencies at the sum and difference of the originals. This is basic physics. Expected, predictable, but not all the frequencies fit this explanation. There is a peak in the spectrum around 1,500 years that appears consistently across multiple ice cores from different locations. This is the Dansgaard-Oeschger frequency, and there is no known orbital or harmonic explanation for it. It doesn't match any combination of Milankovitch cycles. It doesn't correspond to any known astronomical phenomenon. It simply exists, persistent and regular throughout the glacial periods. Some researchers have proposed that it represents an internal oscillation of Earth's climate system, a natural resonance frequency, like the way a pendulum swings at a particular rate determined by its length. Every system has natural frequencies at which it prefers to oscillate. Perhaps Earth's climate, when in a glacial state, naturally oscillates on a 1,500-year cycle due to the interaction between ice sheets, oceans, and atmosphere. This is possible. Resonance is a real phenomenon. But resonance requires a specific geometry, a specific configuration of physical properties. And Earth's climate is not a simple pendulum. It's a vastly complex system with countless interacting components, each with its own timescales, its own feedback loops, its own nonlinear behaviors. For such a system to produce a single, clean resonance frequency that persists for tens of thousands of years across multiple glacial periods with different ice sheet configurations and different atmospheric compositions is unlikely. Not impossible, but unlikely, unless the geometry was deliberate, unless the system was configured to resonate at that frequency, unless the ice, the ocean, the atmosphere were arranged in such a way that they would naturally oscillate on a 1,500-year cycle, and that arrangement was not accidental but designed. There is a precedent for this kind of thinking, though it exists far outside climate science. In architecture, ancient structures sometimes display acoustic properties that seem too sophisticated to be accidental. The whispering galleries in cathedrals where a word spoken at one point can be heard clearly 100 feet away. The resonance chambers in Neolithic tombs that amplify certain frequencies. The acoustic properties of Mayan pyramids where clapping your hands at the base produces an echo that sounds like a quetzal bird. Some of these are documented accidents, natural consequences of particular geometries. But others are so precise, so tuned, that architects and acousticians believe they were intentional. That the builders understood resonance and designed structures to exploit it, even though they left no written records of their knowledge. Could a planet be designed the same way? Could ice sheets be positioned, ocean basins shaped, atmospheric circulation patterns established, in such a way that the entire system would resonate at specific frequencies? Could the ice ages themselves be a kind of planetary architecture, built to oscillate in particular patterns for particular purposes? The mathematics doesn't rule this out. In fact, the mathematics almost suggests it. Because when researchers try to model ice age cycles using only known physical processes, orbital forcing, ice albedo feedback, carbon cycle dynamics, ocean circulation, the models produce ice ages, but not the ice ages we observe. The timing is wrong. The amplitude is wrong. The regularity is missing. To make the models work, scientists have to add what they call stochastic forcing, random noise that represents all the small, unpredictable variations in climate that aren't explicitly modeled. Solar flares, volcanic eruptions, variations in cosmic ray flux, all the chaos that nature generates. But here's the strange part. The stochastic forcing required to make the models match reality is not actually random. It has structure. It has periodicities. When researchers analyze the noise they're adding to their models, they find that it contains the same mysterious frequencies that appear in the real climate data. The 1,500-year cycle, the 5,000-year cycle, all the periodicities that don't have orbital explanations, which means the random forcing isn't random at all. It's periodic, regular, structured. And if the forcing is structured, then it's not noise. It's signal. Signal implies source, and a source that can generate periodic forcing on a planetary scale, that can maintain coherent oscillations across tens of thousands of years, that can do so while remaining invisible to every instrument and observatory humanity has ever built. is not a natural source. Not in any conventional sense. It would have to be something that operates outside the observable parameters. Something that influences climate without leaving direct traces. Something that knows how to push a planet's climate system at exactly the right frequencies to maintain resonance, to keep the ice ages cycling with mechanical precision. Something that understands mathematics better than we do. And perhaps that's the real message hidden in the numbers. Not that the ice ages are engineered, but that they are mathematical. That they follow rules we haven't discovered yet. Rules that look like physics, but might be something else. Something that includes physics, but extends beyond it into territories that science has not yet mapped. The ancients believed that numbers had power, that certain ratios were sacred, that the universe was built from mathematical harmonies, and to understand those harmonies was to understand the mind of the Creator. Modern science abandoned this view, relegating it to mysticism and numerology. But what if the ancients were right in a way they couldn't articulate? What if the universe really does operate according to hidden mathematical structures, and what we call natural laws are just the visible surface of those structures? What if the ice ages are not weather events, but mathematical events? Not accidents of orbital mechanics, but manifestations of deeper patterns? Patterns that repeat because they must repeat, because they are part of the fundamental architecture of how planets work, how intelligence evolves, how time itself unfolds. The equations cannot tell us this. They can only show us that something is missing, that the numbers don't quite add up, that the pattern is too perfect to be explained by the forces we understand. And in that gap between what the equations predict and what actually happens, in that space where the models require adjustment and tuning and mysterious forcing to match reality, there is room for other explanations. Explanations that involve not randomness, but intention. Not chaos, but composition. Not the blind mechanics of orbits and ice, but something that uses those mechanics the way a musician uses strings and air, to create patterns, harmonies, rhythms that serve purposes beyond mere physics. The ice remembers these patterns. The cores preserve them. And as we drill deeper, as we extract records spanning millions of years instead of mere hundreds of thousands, we may find that the patterns extend further back than we imagined, that they are older than the Pleistocene, older than humanity, perhaps as old as Earth itself. And if that is true, then the question is not whether the ice ages were engineered. The question is, what were they engineered for? What purpose requires 2.5 million years of alternating freeze and thaw? What design requires the planet to cycle between ice and warmth with such precision? What could possibly be worth the extinction of thousands of species, the burial of entire continents, the sculpting of landscapes and ecosystems according to rhythms that exist nowhere else in nature? The mathematics offers no answer. Only the pattern. Only the signal. Only the knowledge that something shaped these cycles and left its signature written in frequencies that should not exist. But intelligence leaves more than mathematical traces. It leaves structures, tools, artifacts. And if the ice ages were shaped by intelligence, then somewhere beneath the glaciers, buried in the layers we have not yet reached, there might be evidence more concrete than numbers. There might be architects, or their ruins, or something that served them, something still waiting beneath Greenland's ice, beneath Antarctica's frozen silence, in places we have mapped but not yet understood. There is a problem with searching for ancient civilizations. The problem is time, not the passage of time itself, but what time does to evidence, what it erases, what it transforms into something unrecognizable. Consider a modern city, steel and concrete and glass. Millions of tons of manufactured material arranged in towers and roads and networks of infrastructure. It seems permanent, eternal, but leave it unattended for a century and the forest returns. Vines climb the walls. Roots crack the foundations. Rain seeps into cracks and freezes and splits the concrete. Within 1,000 years, most of the city has collapsed. Within 10,000 years, almost nothing recognizable remains. A few fragments of harder stone, some traces of metal, rusted and scattered. Patterns in the soil where foundations once stood. And 10,000 years is nothing. A blink. A single cycle between glacial and interglacial. The ice ages span 2.5 million years, 250 cycles of freeze and thaw. Each glacial period lasting 90,000 years, glaciers miles thick grinding across continents, pulverizing everything beneath them into powder, scraping bedrock clean, rearranging entire landscapes. If a civilization existed before the ice ages began, and if that civilization's cities were in the path of the glaciers, then those cities are gone. Not buried, not preserved, gone. Ground to dust and mixed into the sediment layers of ancient lake beds, indistinguishable from natural erosion. This is what makes the search difficult. Absence of evidence is not evidence of absence, but it's also not evidence of presence. How do you look for something that time and ice have completely erased? How do you prove that something existed when the very forces you're investigating would have destroyed all proof? You look for what ice cannot destroy, for traces that persist not because they were strong, but because they were placed where the ice couldn't reach, or because they were made of things that don't erode, or because they exist not as physical objects, but as patterns, patterns in the genome, in the distribution of species, in the deep structure of the planet itself. And you look for anomalies, for things that should not exist if history unfolded the way we think it did, for evidence that doesn't fit the narrative of slow, linear progress from primitive to sophisticated, for signs that intelligence existed before it was supposed to, in forms we might not recognize as intelligence because they don't match our expectations of what intelligence looks like. There are such anomalies. Not many, not obvious, but persistent enough that they appear in research papers, mentioned briefly, cataloged as mysteries, and then left alone because pursuing them leads nowhere that science knows how to go. Geopolymers, for instance. These are stone-like materials created by mixing crushed rock with alkaline solutions, producing a substance that can be molded like concrete but becomes as hard as natural stone. The chemistry required to create geopolymers was supposedly unknown until the 20th century. But some ancient stone blocks, particularly in Egypt, but also in South America and Easter Island, show microscopic structures consistent with geopolymer formation rather than natural stone, as if they were cast, not carved. This is controversial. Most geologists reject the geopolymer hypothesis, arguing that the structures can be explained by natural crystallization processes in sedimentary rock. The debate continues, but the question it raises is simpler than the chemistry. If ancient builders could create synthetic stone, what else could they create? What other technologies might they have possessed that left no traces because they were organic or biodegradable or simply too different from our technology for us to recognize the residue? We assume that advanced technology must look a certain way, must involve metal and electricity and visible infrastructure. But technology is just applied knowledge. It's understanding how natural processes work and using that understanding to manipulate the world. A civilization could be technologically sophisticated without ever smelting metal, could understand genetics without ever building a laboratory, could manipulate climate without ever burning fossil fuels. They would just need to understand the right principles, the leverage points in natural systems, the places where a small input produces large effects, the way a single stone placed correctly in a stream can redirect the entire flow of water. And climate is such a system, full of feedback loops and tipping points. Small changes in ice coverage alter the planet's reflectivity, which alters how much sunlight is absorbed, which alters temperature, which alters ice coverage. Small changes in ocean salinity alter circulation patterns, which alter heat distribution, which alters precipitation, which alters salinity. The system is sensitive, responsive. It can be pushed, if you knew where to push. If you understood the mathematics of orbital forcing, you could wait for the moment when Earth's orbit was most favorable for glaciation, when summer sunlight at high latitudes was at its minimum. And then you could enhance the natural cooling with artificial means. Not much, just enough to tip the balance. Enough to make snow accumulate slightly faster than it melts. Enough to start the feedback loops that would do the rest of the work for you. How would you enhance the cooling? Perhaps by increasing the planet's reflectivity, by seeding clouds, by altering the composition of the atmosphere just slightly, reducing greenhouse gases just enough to lower temperatures by a few degrees. That's all it would take. A few degrees, sustained for a few decades, and the ice would begin to form on its own. Natural processes would take over. The ice albedo feedback would kick in. The glaciers would grow without further intervention. You wouldn't need massive machines or visible infrastructure. You would just need knowledge and a willingness to wait, to set processes in motion knowing they would take millennia to fully develop, to think in timescales that span dozens of human lifetimes. This requires a particular kind of intelligence, not the kind that builds cities and writes books and records its history for future generations, but the kind that thinks in geological time, that plans across ice ages, that understands that some problems cannot be solved quickly, can only be guided slowly, patiently, by nudging systems that are already poised to change. Perhaps this is the intelligence that engineered the ice ages. Not a civilization in the sense we understand. No empires, no monuments, no written language carved into stone. But something else. Something that existed in the warm period before the Pleistocene began. 3 million years ago when Earth was stable and temperate and had been so for tens of millions of years. What would such a civilization look like? Perhaps nothing like ours. Perhaps they built with biology instead of stone. Engineered organisms the way we engineer machines. Grew their cities instead of constructing them. Used living systems as their technology. Systems that would die and decompose and leave nothing behind but genetic traces, anomalies in the evolutionary record that we would mistake for natural mutations. There are such anomalies. Species that appear suddenly in the fossil record without clear ancestors. Evolutionary leaps that happen too quickly to be explained by gradual selection. Convergent evolution that produces the same complex structure, like the eye or the wing, multiple times in completely unrelated lineages, as if following a template rather than discovering solutions independently. Science explains these anomalies through various mechanisms. Punctuated equilibrium, genetic drift, the incompleteness of the fossil record. All valid explanations. All probably correct in most cases. But they leave room for other possibilities. For the idea that evolution, at certain critical moments, was not entirely blind. That certain traits were introduced deliberately, woven into the genome, where they would persist and spread and shape the future course of life. Why would anyone do this? Perhaps because they understood that intelligence cannot survive alone, that consciousness requires an ecosystem, that to preserve themselves, they needed to preserve the planet. And to preserve the planet, they needed to reset it, to clear away the unsustainable patterns of their own success and create conditions under which life could begin again, simplified, resilient, capable of surviving the long cold they were about to initiate. So they engineered the ice, not to destroy, but to preserve, not as catastrophe, but as hibernation, a way to slow everything down, to put the planet into a state where change happens slowly, where runaway processes are dampened, where life exists but doesn't consume, doesn't expand, doesn't burn through resources the way warm period ecosystems inevitably do. And then, having set these processes in motion, they stepped back. Or they didn't step back, they stepped in. Into the ice. Into the deep places where glaciers would form and remain stable for hundreds of thousands of years. Where they could wait out the cycles they had initiated. Where they could sleep through the ages they had engineered, preserved in cold and darkness until the planet warmed again and conditions returned that would allow them to wake. This is speculation. Fantasy, perhaps. There is no evidence for sleeping civilizations beneath the ice. No proof of biological technology that dissolved without trace. No confirmation that evolution was ever anything but natural selection operating on random mutations. But there is the Silurian hypothesis, a thought experiment proposed by two climate scientists, one from NASA, one from the University of Rochester, in a peer-reviewed paper published in 2018. They asked a simple question. If an industrial civilization had existed on Earth millions of years ago, how would we know? What traces would remain? Their conclusion was sobering. Almost nothing would remain. Plastics break down. Metals corrode and disperse. Even nuclear waste decays to background levels. Cities erode. Infrastructure crumbles. On geological timescales, millions of years, almost all evidence of civilization vanishes. The only traces that might persist would be indirect, isotopic anomalies in sediment layers, showing sudden spikes in carbon or nitrogen that indicate rapid industrial activity. Changes in fossil pollen distributions that suggest artificial landscaping. Extinctions that correlate with no known natural catastrophe. The paper was intended as a thought experiment, not a serious claim. The scientists were exploring what kind of evidence we should look for in Earth's geological record if we wanted to detect ancient industrial civilizations. They were also making a point about how our own civilization will appear to far future geologists as a thin layer of unusual chemistry, a brief spike in the sediment record, and then nothing. But the thought experiment opens a door. Because if industrial civilizations leave almost no trace, then civilizations using different technologies, biological, chemical, atmospheric, might leave even less. They might leave nothing at all except the effects of their actions, except the changes they made to the planet, except the climate they engineered. And the ice ages are certainly a change. The most dramatic climate shift in the last 100 million years. Before the Pleistocene, Earth had no regular ice age cycles. The planet was warm and stable. Then, suddenly, in geological terms, the cycles began. Ice advanced and retreated with clockwork regularity. And those cycles are still operating. We are living in an interglacial period that, statistically, should end within the next few thousand years. The ice should return. The glaciers should advance again, unless something prevents them, or unless their purpose has been fulfilled. What purpose could ice ages serve? What benefit justifies 2.5 million years of frozen continents and mass extinctions? One answer is obvious: selection pressure. Ice ages force evolution. They test every species, every adaptation, every survival strategy. Creatures that can't handle cold die. Creatures that can adapt, survive, and change. Intelligence, in particular, thrives under pressure. Problem-solving, tool use, social cooperation, language, all of these traits become survival advantages in Ice Age conditions. Humans evolved during the Ice Ages. We are literally products of that pressure. Our brains enlarged, our societies complexified, our technologies developed, all in the narrow refuges between advancing glaciers. The ice shaped us, made us what we are. And perhaps that was the point. Perhaps the Ice Ages were not about preserving an old civilization, but about creating a new one. about engineering conditions that would force intelligence to emerge in species that had the potential but lacked the motivation, about applying pressure, sustained across millennia, sufficient to transform clever apes into something capable of abstract thought, long-term planning, technological innovation, into something capable of understanding what had been done to them. And why? This is a disturbing thought. It suggests that humanity is not accidental, that our intelligence was cultivated, that the struggles of our ancestors, the hunger, the cold, the constant survival pressure, were not random hardships but deliberate tests, that we are, in some sense, the product of an experiment that began millions of years before we existed. But experiments have purposes. Tests have goals. If the ice ages were designed to produce intelligence, then the question becomes, for what? What use is human consciousness to whatever initiated the cycles? What role were we shaped to fill? Perhaps we are meant to be the next architects, the inheritors of a responsibility we don't yet understand. Perhaps the ice ages were designed with an endpoint in mind. The emergence of a species intelligent enough to take over the management of the planet's climate, to continue the work of maintaining habitability, of steering Earth through the dangers that arise on astronomical timescales. Or perhaps we are simply the memory keepers, the consciousness that will eventually piece together what happened, who initiated the cycles, and why. The species that will discover the truth buried beneath the ice and decide what to do with that knowledge. Either way, we are connected to the ice ages in ways deeper than we realize. We are not observers of this process, but products of it. Our existence is not separate from the glacial cycles, but woven into them. We are the children of engineered winter, born from cold and pressure and the slow grinding of continental ice. And somewhere in our genome, in the deep structures of our brain, in the way we think and feel and remember, there might be traces of the architects who designed these conditions. Fingerprints left not in stone or metal, but in the pattern of our neurons, the architecture of our consciousness, the instincts we carry without knowing why. We dream of ice. We tell stories of ancient floods. We remember, in myths and legends scattered across every continent, that the world was once different, that something happened, that the gods, or something like gods, reshaped the earth. And though we call these stories mythology, dismiss them as primitive explanations for natural phenomena, perhaps they are memory, distorted, metaphorical, passed down through so many generations that the details are lost, but the core truth remains. Someone changed the world. Someone brought the cold, and the cold is not finished with us yet, because the patterns are still operating. The cycles are still turning, and what was engineered once might be engineered again. If the architects still exist, still wait, still watch from places where ice preserves what warmth destroys. There are atoms that remember, not consciously, not the way living things remember, but through their structure, through the number of neutrons bound to their nucleus. Oxygen, for instance, exists in 3 stable forms. Oxygen, 16, the common kind, has 8 protons and 8 neutrons. Oxygen, 17 has 9 neutrons. Oxygen, 18 has 10. Chemically, they behave almost identically, but physically, they are different, heavier. The extra neutrons make them sluggish, harder to evaporate, slower to move through water and air. And this difference, this tiny variation in weight, creates a record, a chronicle written in the ratios of isotopes, preserved in ice and stone and the shells of ancient creatures. Because when water evaporates from the ocean, it preferentially takes the lighter isotopes, oxygen, 16 over oxygen, 18. The heavier isotopes stay behind. But when that water vapor condenses and falls as rain or snow, the reverse happens. The heavier isotopes condense first. The lighter ones stay in the air longer, travel farther, fall later. The result is a sorting, a fractionation. Water that evaporates at the equator and falls as snow at the poles is depleted in oxygen, 18 compared to ocean water. And the colder it gets, the more pronounced this depletion becomes. Ice formed during glacial periods has a different isotope ratio than ice formed during warm periods. The ratio is a thermometer, a chemical record of temperature frozen into the crystal structure of ice. Scientists drill these thermometers out of Antarctica and Greenland. They extract cylinders of ice that span hundreds of thousands of years. They measure the oxygen isotope ratios in each layer, plot them on graphs, and watch as the temperature history of the planet unfolds. Warm periods show higher ratios. Cold periods show lower ratios. The pattern matches what orbital mechanics predicts, more or less. But when you look closely at the isotope data, when you zoom in on specific transitions, specific moments when the climate shifted from one state to another, you find anomalies. Small deviations, ratios that don't quite fit the smooth curve that natural fractionation should produce. There are spikes, brief excursions where the oxygen 18 ratio jumps or drops by an amount inconsistent with gradual temperature change. These spikes last only a few years, sometimes only a single year, buried within the larger trends. They're small enough that they could be measurement errors, noise in the data, natural variation, but they appear in multiple ice cores from different locations. The same anomalies at the same times, preserved independently in ice sheets thousands of miles apart, which means they're real. Which means something happened in those years. Something that altered the isotope ratios in precipitation across large regions of the planet. What could do that? Volcanic eruptions, possibly. A massive eruption could inject enough sulfate aerosols into the stratosphere to alter atmospheric circulation patterns, changing where and how water vapor condenses. This would affect isotope ratios. But volcanic eruptions leave other signatures: ash layers, sulfate spikes, acidity changes in the ice. And many of the isotope anomalies occur without any corresponding volcanic signature. Meteor impacts could also cause anomalies. The heat and shock wave from a large impact would vaporize vast amounts of water, disrupting normal fractionation patterns. But impacts leave even more obvious traces than volcanoes. Impact spherules, iridium anomalies, soot layers from global wildfires. And again, most of the isotope spikes have no impact signature. So what's left? What could change the isotope ratios in precipitation without leaving any other detectable trace? What could affect the atmosphere's chemistry so precisely that only the oxygen isotopes record it? The only answer that fits is atmospheric intervention. Something that altered the composition or circulation of the atmosphere directly, without the side effects of volcanic eruptions or impacts. Something that changed how water vapor moved and condensed, but left no ash, no debris, no chemical residue except the altered isotope ratios themselves. This is not a natural process. Natural atmospheric changes, even rapid ones like those caused by orbital forcing or ocean current shifts, produce gradual isotope variations. They don't produce single-year spikes. They don't affect multiple regions identically without affecting anything else. The spikes suggest control, precision, an understanding of atmospheric chemistry sophisticated enough to alter isotope fractionation deliberately, perhaps as a calibration step, perhaps as a test, perhaps as part of a larger process of climate management that required fine-tuning the atmospheric parameters. And then there is carbon. Carbon, 12, is the common form, 6 protons and 6 neutrons. Carbon, 13, has 7 neutrons. Carbon, 14, radioactive and unstable, has 8. The ratios between these isotopes tell different stories than oxygen. They speak of life, of photosynthesis, of organic processes. Because plants prefer carbon-12 when they build their tissues. It's lighter, easier to incorporate into molecules. So living things become depleted in the heavier isotopes compared to the atmosphere. When plants die and decay, when forests burn, when organic carbon is buried and compressed into coal or released as carbon dioxide, the isotope ratios shift. Ice cores contain tiny bubbles of ancient air, trapped atmosphere from thousands of years ago, sealed within ice as it formed, preserved unchanged. Scientists can extract these bubbles, measure the carbon dioxide concentration, measure the carbon isotope ratios, and reconstruct not just how much CO2 was in the atmosphere, but where it came from. Whether it was released from the ocean, from volcanic activity, from decomposing organic matter, from burning forests. And the ratios are strange. During certain periods, particularly during the rapid warming events that mark the transitions out of ice ages, the carbon isotope ratios in atmospheric CO2 show signatures that don't match any known natural source. The ratios suggest carbon that came from deep ocean reservoirs, but the release happened too quickly for normal ocean circulation to explain. Or they suggest organic carbon released through decomposition, but the volume is too large to come from available biomass. Or they show mixing patterns that would require atmospheric circulation different from what climate models predict for those time periods. These anomalies are documented in the scientific literature. They're labeled as unexplained. Researchers propose various mechanisms: methane clathrate destabilization, permafrost carbon release, changes in ocean ventilation, but none of the mechanisms fully account for the observations. The carbon appears too quickly, in ratios that don't quite fit, from sources that should have been too deep or too frozen to release it that fast. It's as if something was adding carbon to the atmosphere deliberately, injecting it in carefully calculated amounts to enhance the natural warming that orbital cycles had initiated. Using the planet's own carbon stores as a tool, releasing them at precisely the right moment to trigger feedback loops that would amplify the warming, that would melt the ice sheets faster than they would have melted on their own. Why would anyone do this? If the ice ages were engineered, if they served a purpose, why would the engineers also engineer their termination? Why not let the ice retreat naturally when orbital mechanics favored warming? Perhaps because natural termination takes too long. Perhaps because the transition needs to happen quickly to prevent ecological collapse. When ice sheets retreat slowly, they leave behind barren landscapes that take centuries to recolonize. But when they retreat quickly, when the warming is rapid, life can migrate faster, can follow the retreating ice edge, can establish itself before the conditions change again. Rapid termination minimizes the extinction events. It gives species a chance to adapt and survive rather than dying in the no-man's land between ice and inhabitable territory. Or perhaps the timing matters for other reasons. Perhaps the interglacial periods, the warm breaks between ice ages, need to begin at specific moments. Not just when orbits align, but when other factors also align. Astronomical factors we don't understand. Galactic factors. The solar system's position in its orbit around the Milky Way's center. The alignment of planets. The flux of cosmic radiation. Variables that operate on timescales so long that we don't notice them, that don't appear in our equations because we've only been measuring them for decades, and they cycle over millions of years. If such factors matter, if the timing of warmth is crucial for reasons beyond climate, then the termination of ice ages would need to be controlled, orchestrated, made to happen at the right moment, regardless of what orbital mechanics alone would dictate. And the way to control it would be through the carbon cycle, through the greenhouse effect, through understanding exactly how much CO2, released at exactly the right rate, would trigger exactly the right amount of warming. The ice remembers these releases. The bubbles preserve them. The isotope ratios record them. Not clearly enough to prove deliberate action, but clearly enough to show that something about the carbon releases during glacial terminations is inconsistent with our models of natural processes. And carbon is not the only element that tells strange stories. Nitrogen isotopes show similar anomalies. The ratio of nitrogen, 15 to nitrogen, 14 in ice core air bubbles varies in ways that suggest changes in the nitrogen cycle. Changes in how much nitrogen was being fixed by bacteria, cycled through ecosystems, released back to the atmosphere. These changes should correlate with temperature and ecosystem productivity. Warmer periods should show higher biological activity, more nitrogen cycling. Colder periods should show less. But the correlation isn't clean. There are periods during ice ages when nitrogen cycling appears to have been elevated despite cold temperatures. Periods when the nitrogen isotopes suggest productive ecosystems in regions that should have been frozen wastelands. As if something was maintaining biological activity artificially. As if certain areas were being kept warm, kept alive, while the rest of the planet froze. Refugia, perhaps. Pockets of warmth maintained deliberately to preserve seed populations of species. Living museums where the biodiversity of warm periods was stored, protected, kept viable until the ice retreated and those species could spread again. This would require energy. Geothermal heat, perhaps tapped and distributed. Or some other energy source we don't have a name for. Something that could warm specific regions without warming the entire planet, without leaving obvious traces except subtle changes in the nitrogen cycle, isotope ratios that suggest life persisting where life should have been impossible. These are speculations built on the faintest of evidence, on anomalies that might be measurement errors, on ratios that might have natural explanations we simply haven't discovered yet. The scientific consensus is that ice core isotopes, while complex and sometimes puzzling, do not require extraordinary explanations. The anomalies are within the range of natural variation. The system is complicated enough that unusual ratios can emerge from unexpected interactions between known processes. This is probably true. Extraordinary claims require extraordinary evidence. And isotope anomalies, however persistent and perplexing, are not extraordinary enough. They are merely suggestive. Hints, whispers in the chemical record that say, something about this doesn't fit. Something about the way carbon and oxygen and nitrogen were moving through the atmosphere during ice ages differs slightly from what natural processes alone should produce. Whispers are easy to ignore. Science requires replicable experiments, testable hypotheses, mechanisms that can be explained with equations. Whispers don't meet that standard. So they remain in the margins of research papers, briefly noted and then set aside. Anomalies waiting for better theories. Patterns that might become significant if we could see them in context, if we understood what we were looking at. But the isotopes remember. They don't forget. Don't deteriorate, don't fade with time. The ratios are locked into the crystal structure of ice, preserved as precisely as the day the snow fell. And as we drill deeper, as we extract cores that span not just hundreds of thousands of years but millions, we may find that the anomalies extend further back than we expected, that they are not random fluctuations but persistent features. That they tell a story that has been running for far longer than the ice ages themselves. A story written in the language of atoms, in the weight of neutrons, in the subtle mathematics of fractionation and decay. A story that says, someone was here, someone who understood chemistry well enough to alter it, someone who knew how to change the atmosphere without leaving fingerprints in anything except the isotopes. Someone who worked with precision and patience, adjusting the climate degree by degree, ratio by ratio, until the planet responded the way they intended. The isotopes remember, even if we have forgotten, even if we never knew. The chemical memory persists, waiting in the ice, in the deep places where temperature has kept it frozen, where pressure has kept it pure, where time has kept it hidden until the moment when we finally learn to read what it says. There are other chemicals trapped in ice, not just the major components, oxygen, nitrogen, carbon, but trace elements. Molecules present in parts per billion, barely detectable even with sophisticated instruments. But these traces matter. They tell stories that the major elements cannot. Methane, for instance, it appears in ice core records as tiny concentrations in the trapped air bubbles. During warm periods, methane levels are higher. During cold periods, they drop. This makes sense. Methane is produced by wetlands, by decomposing organic matter in waterlogged soils. When the planet is warm, wetlands expand. More methane gets released. When the planet is cold, wetlands freeze. Methane production decreases, but the relationship isn't linear. During some warming events, methane levels spike far higher than the expansion of wetlands could explain. During some cooling events, methane drops, but then plateaus at levels that suggest continued production somewhere, even as global temperatures fall and wetlands freeze. The source of these anomalous methane emissions is debated. Some researchers point to methane clathrates, ice-like structures formed when methane gets trapped in water molecules under high pressure, buried in ocean sediments or permafrost. When these clathrates destabilize due to warming or pressure changes, they can release large amounts of methane suddenly. This could explain the spikes. But clathrate destabilization should leave other signatures. It should affect ocean chemistry. It should show up in sediment records. And in many cases, the methane spikes occur without corresponding evidence of clathrate release. The methane appears in the atmosphere as if from nowhere, spikes suddenly, then disappears just as quickly. What could produce methane in controlled bursts? Biological processes, certainly, but controlled biological processes. Not the random fluctuation of wetland area, but something more deliberate. Engineered ecosystems, perhaps, designed to release methane on demand. Or captured methane stores, held in reservoirs and released when atmospheric chemistry needed adjustment. Methane is a greenhouse gas, far more potent than carbon dioxide. Small releases could have large effects on climate, could push temperatures just enough to trigger ice melt, or prevent ice formation, or maintain warmth in specific regions. The technology required for this is not beyond imagining. We can capture and store methane today. We understand its properties, its effects on climate. A civilization that understood atmospheric chemistry could certainly have developed methods to use methane as a tool, a lever for adjusting temperature with precision. And then there are the sulfur compounds. Sulfates appear in ice cores as markers of volcanic activity. When volcanoes erupt, they inject sulfur dioxide into the atmosphere. It converts to sulfate aerosols, which reflect sunlight and cool the planet. These aerosols eventually fall out of the atmosphere and get preserved in ice as sulfate spikes. Most sulfate spikes in ice cores can be matched to known volcanic eruptions, but not all of them. There are sulfate layers that appear during periods with no corresponding volcanic activity, no ash layers, no other signatures of eruption. Just sulfur, appearing in the stratosphere as if placed there. Natural explanations exist. Perhaps the eruptions occurred in remote locations and weren't recorded. Perhaps they were submarine eruptions that produced no ash but released sulfur gases. Perhaps the sulfur came from biological sources, ocean plankton releasing dimethyl sulfide during periods of unusual productivity. But some of the anomalous sulfate layers are too consistent, too widespread, too precisely timed to be coincidental. They appear during specific climate transitions, during moments when cooling was needed to prevent runaway warming, or when ice formation needed to be accelerated. As if sulfur was being injected into the atmosphere deliberately, not by volcanoes, but by design, to create the cooling effect that volcanic eruptions produce naturally. Geoengineering, in other words, solar radiation management. The same techniques that modern climate scientists propose for combating global warming, techniques that involve spraying sulfate aerosols into the stratosphere to reflect sunlight, may have been used millions of years ago, may have been part of the toolkit that Ice Age engineers used to control temperature, to maintain the glacial cycles, to ensure that ice advanced and retreated according to schedule. The evidence is circumstantial, suggestive rather than conclusive, but it accumulates. Oxygen isotopes that shift too quickly, carbon releases that don't match natural sources, methane spikes without corresponding wetland expansion, sulfate layers without volcanic eruptions. Each anomaly small, each explainable, perhaps, through some combination of natural processes we don't fully understand. But together, they form a pattern, a constellation of chemical oddities that cluster around climate transitions, that appear when the planet shifts from one state to another, that suggest intervention at crucial moments, adjustments made to guide natural processes toward specific outcomes. The ice cores are archives, chemical libraries. Every layer a page, every isotope ratio a word, every trace element a footnote. And if you read them carefully, if you look not just at the major text but at the marginalia, the corrections, the places where the narrative doesn't quite flow smoothly, you begin to see edits, changes, signs that the story as written is not quite the story as it happened naturally. Someone edited the climate, adjusted the chemistry, left fingerprints in the isotopes, because isotopes are fundamental. You can't alter atmospheric processes without altering the isotope ratios that result from those processes. The fingerprints are faint, deniable, subject to interpretation, but they are there. And as we develop more sophisticated methods of analysis, as we extract deeper cores and measure more elements with greater precision, we may find that the fingerprints become clearer, that the anomalies are not random but systematic, that they occur in patterns that correspond to nothing natural but everything intentional. The isotopes remember what we never knew. They preserve evidence of actions taken before memory, before history, before consciousness as we understand it existed on this planet. They are the closest thing we have to a chemical fossil record of intelligence, not biological intelligence preserved in bones and tools, but atmospheric intelligence preserved in ratios and traces, in the ghost chemistry of a climate that was shaped, maintained, controlled by something that understood how planets work and how to change them. But chemistry alone cannot prove intention. It can only demonstrate anomaly. To move from anomaly to explanation requires physical evidence, structures, technology, something concrete buried beneath the ice, preserved by the very cold that it may have helped create. Something waiting in Greenland, in Antarctica, in the places where radar sees shapes that geology cannot explain. There is a sound that radar makes when it encounters something unexpected, not a literal sound. The radar itself is silent, electromagnetic pulses bouncing off ice and rock and whatever lies between. But on the screens where scientists watch the data return, there is a visual equivalent of dissonance, a pattern that breaks, a signal that refuses to fit the expected geometry of glacial ice and bedrock. Greenland is buried beneath ice, not just covered, but entombed. In some places, the ice is 3 kilometers thick, almost 2 miles of frozen weight pressing down on whatever landscape existed before the glaciers came. That landscape is invisible from the surface, hidden, preserved or destroyed or transformed by the pressure and the slow grinding movement of ice that has been there for 100,000 years. To see what lies beneath, scientists use radar. Ice-penetrating radar, mounted on aircraft that fly grid patterns over the ice sheet, sending pulses of electromagnetic radiation downward, measuring how long it takes for the echoes to return. Ice is relatively transparent to these frequencies. The pulses pass through. But when they encounter rock or water or anything with different electrical properties than ice, they reflect, return, and from the pattern of reflections, a map emerges. A hidden topography, the ghost of Greenland as it was before the ice. Most of what the radar reveals is expected. Mountains buried under ice, valleys filled with glacial flow, the bedrock contours that geology predicts. But not everything is expected. Not everything fits. In 2013, a radar survey detected what appeared to be a crater beneath Greenland's ice sheet. Circular, 30 kilometers across, the right size and shape to be an impact structure from a large meteor. The researchers announced the discovery, published their findings, noted that the crater was relatively young, probably less than 3 million years old, possibly much less. They suggested it might have been formed during the Pleistocene, perhaps even during the most recent ice age. An impact during an ice age would have been catastrophic. The energy released by a meteor large enough to create a 30-kilometer crater would have vaporized billions of tons of ice instantly, would have thrown debris into the stratosphere, would have caused rapid climate changes, possibly triggering the kind of abrupt warming events that show up in ice core records as unexplained transitions. But there were problems with this interpretation. The crater showed no signs of deformation from glacial movement. Ice flowing over it for thousands of years should have warped its structure, softened its edges. But the crater appeared pristine, sharp, as if it were very recent, or as if it had been protected somehow from the grinding pressure of the ice above. And then there was the location. The crater sat beneath one of Greenland's fastest-flowing ice streams, a region where ice moves not slowly through compression but rapidly through sliding, lubricated by meltwater at its base. This meltwater shouldn't exist. The ice is too thick, too cold, but radar shows it there anyway. A layer of liquid water between ice and bedrock, allowing the ice to flow faster than it should. The presence of meltwater suggests heat. Geothermal heat, presumably, rising from Earth's interior. But Greenland is not volcanically active. It sits on ancient, stable crust far from any tectonic boundaries. There is no obvious source for the heat required to melt ice at the base of a 3-kilometer thick glacier. Unless the heat is not coming from below. Unless it's coming from within the crater itself. From whatever created the crater, or whatever the crater contains. This is speculation. The researchers who discovered the crater have not suggested anything of the sort. They have proposed natural explanations for the meltwater, friction from ice movement, perhaps generating heat through sheer mechanical stress, or residual heat from the impact itself, if the crater is young enough, or variations in crustal thickness creating localized geothermal anomalies. All plausible, all reasonable, all more likely than the alternative. But the alternative persists in the margins of discourse, in the questions that don't get asked in official papers, but circulate in informal discussions, in late-night conversations between researchers who have seen too many anomalies to dismiss them all as coincidence. Questions like, what if the crater is not an impact structure but something else? What if it's a constructed feature, deliberately circular, deliberately positioned beneath ice that would hide it and preserve it? What if the heat is not residual but active, generated by something still functioning beneath kilometers of frozen weight? There are other anomalies, not just the crater. Greenland's ice sheet has been surveyed extensively over the past 2 decades. multiple radar campaigns, multiple frequencies, multiple institutions processing the data independently. And in that data, scattered across different surveys and different depths, are signatures that resist simple geological explanation. Linear features, for instance, long, straight reflections that run for kilometers beneath the ice. Too straight to be natural rock formations. Too regular to be glacial valleys. They show up in multiple radar bands, which means they're real, not artifacts of signal processing or atmospheric interference. But no one knows what they are. The official designation is subglacial structural anomalies. The unofficial speculation ranges from ancient river channels, carved when Greenland was ice-free and water flowed across its surface, to fault lines in the bedrock. Both explanations are possible. Rivers can carve straight channels when they follow geological weaknesses. Faults can create linear features when rock fractures along stress lines. But rivers meander. Even when constrained by geology, they curve, branch, rejoin. And these features don't meander. They run straight, parallel to each other in some cases, intersecting at precise angles in others. Like a grid, like something planned. And then there are the reflections that shouldn't exist at all. Radar works by detecting boundaries between materials with different electrical properties. Ice has one set of properties. Rock has another. Water has another. When radar encounters these boundaries, it reflects. But some of the reflections from beneath Greenland's ice don't match any known material. They're too strong to be rock, too persistent to be water, too localized to be ice with unusual crystal structure. They appear as bright spots on radar displays. Hyperreflective zones. Small, usually less than 100 meters across, scattered seemingly at random beneath the ice sheet. Geophysicists call them anomalous reflectors and attribute them to pockets of mineralized water or concentrations of metallic or unusual rock compositions. But metallic or shouldn't be present in sufficient concentration to create such strong reflections. And the bright spots don't correlate with known mineral deposits. They appear in areas where geological surveys show ordinary bedrock, granite, gneiss, the ancient metamorphic rocks that form the stable continental cores. Some of them correlate with the linear features. Bright spots at intervals along the straight lines, like markers, like beacons, like nodes in a network that extends beneath the ice, invisible from the surface, preserved in frozen darkness. No excavation has been attempted. Greenland's ice is too thick, too remote, too technically challenging to drill through just to investigate radar anomalies that probably have mundane explanations. The few deep drilling projects that have reached bedrock have focused on retrieving ice cores for climate research, not on investigating the rock beneath. And those projects are expensive, years in planning, politically complex. They require international cooperation, environmental impact assessments, funding from multiple agencies. No one wants to propose drilling to investigate something that might be nothing. That probably is nothing. That almost certainly has a natural explanation if only we understood the geology better, if only the radar resolution were higher, if only we had ground truth data from more locations. So the anomalies remain. Documented. Published in specialized journals. Mentioned briefly in survey reports. Filed away as curiosities that future research might explain. But not pursued. Not prioritized. Not considered worth the expense and effort when so many other questions about ice sheet dynamics and climate history demand attention. And perhaps that is appropriate. Science must allocate resources rationally, must pursue questions that have clear methodologies and probable answers, cannot chase every anomaly, cannot investigate every unexplained signal. Some mysteries must wait. But while they wait, the ice is melting. Greenland's glaciers are retreating at accelerating rates. The weight of ice pressing down on the bedrock is diminishing. The protective layer that has hidden whatever lies beneath for 100,000 years is thinning. Within this century, possibly within decades, some of the areas showing radar anomalies may become exposed. The ice will retreat. The bedrock will emerge. And whatever has been preserved there, whatever has been generating those inexplicable reflections, will become visible, or it already is visible in places. Greenland's margins, where glaciers meet the sea, are dotted with exposed rock. Cliffs and valleys and coastlines that have been ice-free for years or decades as the glaciers retreat. And in some of those exposed areas, there are formations that geologists struggle to explain. Rocks arranged in patterns too regular to be natural erosion. Boulders positioned in ways that suggest placement rather than glacial transport. Depressions in bedrock that look carved, shaped, intentional. Most of these are probably natural. Rock erodes in patterns. Glaciers move boulders. Nature creates geometry without intention all the time. But not all of it is easily dismissed. Not all of it fits the expected categories. Some of it looks deliberate. There is a valley in eastern Greenland that was exposed when a glacier retreated in the early 2000s. The valley walls show striations, grooves carved into rock. Glacial striations are common, created when rocks embedded in moving ice scrape against bedrock. But these striations were vertical, parallel to each other, evenly spaced, running down the valley walls in lines that looked less like glacial scoring and more like writing, like marks made by something that moved deliberately, that repeated the same motion over and over, that left a pattern meant to convey information. The geologists who documented these formations noted their unusual regularity. They photographed them. They proposed explanations involving unique glacial dynamics, unusual rock composition, uncommon erosion patterns. The formations were filed in geological databases, labeled as atypical striations, and left for future researchers to revisit if anyone develops a better theory. No one has. The striations remain unexplained, visible now, accessible, but ignored because they are anomalies, and anomalies without clear investigative pathways get set aside. They accumulate in the literature like sediment, layers of unresolved observations building up slowly, waiting for someone to recognize them as a pattern rather than as isolated mysteries. And perhaps that recognition is coming. Perhaps as more of Greenland emerges from beneath retreating ice, as more bedrock becomes visible and mappable and explorable, the scattered anomalies will connect. The bright spots on radar will correspond to actual structures. The linear features will reveal themselves as something other than geological accident. The striations will prove to be language or art, or the marks of machinery we don't yet recognize as machinery. Or perhaps not. Perhaps everything will have natural explanations. Perhaps the anomalies are simply the price of incomplete knowledge, the gaps that exist when surveying is done from aircraft instead of on foot, when interpretation is done from radar data instead of direct observation. But the ice remembers what it hides. And as it melts, as it releases its grip on Greenland's buried landscape, it will reveal what it has preserved. Whether that revelation answers questions or raises new ones, whether it confirms our understanding or shatters it, depends on what has been sleeping there. What has been waiting beneath the ice, beneath the weight and the cold and the darkness, through the long ages when the glaciers ruled and memory froze solid, and the planet forgot everything except the rhythm of advance and retreat. Antarctica holds deeper secrets. It is older, colder, more thoroughly buried than Greenland. The ice there is thicker, in places for kilometers. More than 2 miles of accumulated snow compressed over millions of years into dense, blue ice that has never melted, never moved quickly enough to disturb what lies beneath. Antarctica was ice-covered before the Pleistocene ice ages began, before the northern glaciers formed. It has been frozen for 35 million years, since the continent drifted far enough south and the ocean currents shifted enough to isolate it in permanent cold. Anything beneath Antarctica's ice has been there a very long time, preserved perfectly, or destroyed completely by the weight. There is no middle ground. Either the ice has protected it from erosion and weathering, keeping it intact in frozen suspension, or the ice has crushed it, ground it down, erased it as thoroughly as fire erases paper. Radar surveys of Antarctica have revealed a landscape as varied as any continent's. Mountain ranges buried entirely under ice, valleys that once held rivers, lakes that still hold liquid water, heated by geothermal sources or preserved under pressure. The largest of these is Lake Vostok, but there are others. Hundreds of subglacial lakes, scattered beneath the East Antarctic ice sheet, like hidden jewels, each one a pocket of liquid in a world of solid cold. And some of these lakes show anomalies similar to those in Greenland. Magnetic irregularities. Radar reflections that don't match water or rock. Geometric features on the lake beds, ridges, depressions, formations that look too regular to be natural sedimentation. Lake Vostok's anomalies were discovered in the 1990s during the first comprehensive radar surveys. The lake is enormous, 250 kilometers long, 50 kilometers wide, as large as Lake Ontario. It sits beneath 4 kilometers of ice, completely isolated from the surface world for 15 million years. When researchers first mapped it with radar and seismic soundings, they expected to find a smooth lake bed, sediment accumulated over millions of years of isolation. Instead, they found structure, a magnetic anomaly in the southern portion of the lake, strong enough that it registered on magnetometer readings taken from aircraft flying over the ice, strong enough that it suggested either a massive concentration of magnetic minerals in the bedrock or something else, something that shouldn't be there. The official explanation is that the anomaly represents an unusual geological formation, perhaps a meteorite impact site or an exposure of magnetic rock types not typical for the region. These explanations are plausible. Earth's crust is heterogeneous. Magnetic anomalies occur naturally, but the anomaly's location is suggestive. It sits near what appears to be a ridge or embankment running along one edge of the lake. A linear feature visible in seismic data that doesn't match typical lake bed topography. It's too straight, too high, too consistent along its length, as if it were built rather than eroded, as if it were a wall or a dam or the foundation of something that once stood on the shore of a lake that has been buried beneath ice for longer than humans have existed. No one has seen this structure directly. Drilling to Lake Vostok was attempted in the 2010s, but the project was fraught with difficulties. The ice is too thick, the drilling too slow, the risk of contaminating the pristine lake too great. When Russian researchers finally breached the ice in 2012, they retrieved water samples but could not explore the lake bed, could not send cameras or probes, could not investigate the magnetic anomaly or the linear ridge. They confirmed that the lake contained life, bacteria that had evolved in isolation for millions of years. And then they stopped. The drilling project was suspended. The lake was resealed by ice forming in the borehole. The reasons given were technical and environmental. The drilling equipment was inadequate. The risk of contamination was too high. International protocols required more careful methodology. All true, all valid, but the suspension was permanent. No new drilling has been proposed. No plans exist to return to Lake Vostok, to investigate further, to explore what the radar and magnetic surveys suggest might be there. And this pattern repeats across Antarctica. Anomalies discovered, documented, then abandoned, not through conspiracy or deliberate suppression, but through the simple weight of practical considerations. Antarctica is remote, expensive, dangerous to work in. Scientific funding is limited. Every project must justify itself. And investigating anomalies that probably have mundane explanations cannot compete with projects that will certainly yield useful data about climate or ice dynamics or past atmospheric composition. So the anomalies remain, cataloged in databases, mentioned in survey reports, visible in the radar and magnetic data that anyone with the right clearances can access, but not investigated, not explored, not understood. And perhaps that is how the architects intended it. If there are architects, if the ice ages were designed, if structures or technology or something we don't have words for lies preserved beneath the ice, then the best protection is not concealment, but neglect. Not hiding evidence, but ensuring that evidence remains uninteresting, that it looks like geological anomaly, that it generates no urgency, no curiosity strong enough to overcome the practical barriers to investigation. The ice protects through difficulty, through remoteness, through the sheer technical challenge of drilling 4 kilometers through frozen weight to reach things that are probably just unusual rock formations, probably just natural variations in bedrock composition, probably nothing that warrants the expense and risk. Probably. But the glaciers are melting. Even in Antarctica, even in the deep interior where temperatures stay far below freezing year-round, the ice is thinning at the margins. Glaciers are retreating from the coasts. Ice shelves, the floating extensions of glaciers that spread out over the ocean, are fracturing, calving enormous icebergs, collapsing in events that scientists watch with instruments and satellites but cannot prevent. And as the ice retreats, as the weight lifts, as the frozen seal that has preserved Antarctica's secrets for millions of years begins to break, what has been sleeping beneath might wake. Not literally. Nothing alive could survive that long, that cold, that entombed. But metaphorically, structurally, technologies that were designed to endure, to remain functional, to respond when conditions changed, when the weight lifted, when the ice finally retreated and the possibility of discovery arrived. This is speculation built on speculation, inference stacked on anomaly. There is no evidence that anything beneath Antarctica's ice is artificial. No proof that the magnetic anomalies and radar irregularities represent anything other than geology. No reason to believe that the ice ages were anything other than natural climate cycles responding to orbital mechanics. Except that the pieces don't quite fit. Except that the pattern is too regular. Except that the isotopes whisper of intervention and the mathematics requires variables that shouldn't exist. And now the ice itself is revealing hints of structures that don't match what geology predicts should be there. And if even one of these anomalies turns out to be what it suggests, if even one radar reflection is confirmed as artificial, if even one magnetic signature corresponds to technology rather than mineralization, if even one of the linear features proves to be constructed rather than eroded, then everything changes. Then the ice ages must be reconsidered. Then the question is no longer, what if they were engineered? But how were they engineered, and by whom, and why? The ice knows. It has preserved the answer. And slowly, reluctantly, as the planet warms and the glaciers retreat, it is releasing that answer back into the world. Whether we are ready to receive it, whether we can understand it, whether we even recognize it as an answer rather than just another mystery in a world already full of them. Some truths wait not in what we find, but in what finds us. And what sleeps beneath the ice may already be stirring, responding to the lightning pressure, the returning warmth, the shift from glacial age to interglacial. There is a list, not written anywhere, not carved in stone or preserved in documents, but encoded in the fossil record. A list of species that survived the ice ages and species that did not. And if you study that list carefully, if you look not just at what died, but at the pattern of dying, something strange emerges. The extinctions were not random. This is surprising because natural disasters typically kill indiscriminately. When a volcano erupts, it doesn't spare the beautiful and doom the ugly. When drought comes, it doesn't choose which plants will wither and which will thrive based on their ecological value. Nature is efficient but not selective in the way intelligence is selective. Natural selection operates through blind filtering. Whatever survives, survives. Whatever fits the new conditions persists. Whatever doesn't dies. There is no intent, no purpose, no gardener deciding which flowers to keep and which to pull. But the Ice Age extinctions don't look like that. They look curated. Consider the megafauna, the large mammals that dominated the Pleistocene: mammoths, mastodons, giant ground sloths, saber-toothed cats, dire wolves, short-faced bears, giant beavers the size of black bears, glyptodonts with armored shells like living tanks. These creatures were adapted to Ice Age conditions. They had evolved over hundreds of thousands of years to thrive in cold climates, in open grasslands and tundra, in ecosystems shaped by glaciers. They should have been resilient, should have survived as long as the Ice Ages continued. But they didn't. They died out suddenly, almost all of them, in a wave of extinctions that occurred roughly 12,000 years ago, right at the end of the last glacial period. Right when the ice was retreating and the planet was warming and conditions were shifting from glacial to interglacial. Right when, theoretically, large cold-adapted animals should have been most stressed by warming temperatures. Except that the same species had survived previous warming periods, had lived through multiple interglacials, had persisted through the same kind of climate transitions dozens of times over the past 2 million years. Why would this particular warming event kill them when previous warmings had not? The standard explanation is human hunting. Anatomically modern humans had spread across the continents by this time, armed with sophisticated weapons and coordinated hunting strategies. We killed the megafauna, this theory goes, either through direct overhunting or through indirect pressure, disrupting ecosystems, outcompeting them for resources, introducing diseases. The timing fits. Megafauna extinctions correlate with human arrival in various regions. First in Australia, 40,000 years ago, then Europe and Asia. Finally, the Americas, 12,000 years ago, where the extinction wave was most dramatic. But the correlation is imperfect. Some regions experienced megafauna extinctions before humans arrived. Some species died out in areas where human populations were sparse and hunting pressure minimal. And many large animals survived: bison, elk, moose, bears. If humans were capable of hunting mammoths and mastodons to extinction, why did these other large mammals persist? What made them different? Size is the usual answer. Mammoths were larger, slower to reproduce, easier to drive to extinction. But mastodons were similar in size to moose, and moose survived. Giant ground sloths were no larger than modern elephants, which survived in Africa and Asia. Short-faced bears were terrifying predators, but no more formidable than the grizzly bears that survived in North America or the brown bears that survived in Europe. The pattern of survival and extinction doesn't correlate neatly with size, or reproductive rate, or ecological niche, or any single variable that should determine which species could withstand hunting pressure and which could not. Instead, it looks almost arbitrary, as if someone was selecting which species to preserve and which to remove, as if the extinctions served a purpose beyond natural selection. What purpose could extinctions serve? In natural systems, extinctions clear niches. They remove species that are no longer well adapted, making room for species that fit the new conditions better. This drives evolution forward, creates opportunities for innovation and diversification. But it happens gradually, through continuous pressure, through the slow accumulation of small disadvantages. The megafauna extinctions were not gradual. They were abrupt. Species that had existed for hundreds of thousands of years disappeared within centuries, sometimes within decades. Populations crashed so quickly that they left almost no archaeological trace of their decline. One century, they were everywhere in the fossil record. The next century, gone. This is the signature not of natural pressure, but of systematic removal. And if the extinctions were systematic, then they followed criteria, rules, a logic that determined which species should continue into the modern era and which should end with the Pleistocene. To understand those rules, one must look not just at what died, but at what survived, at the pattern of persistence. Humans survived. Obviously, we are here. But so did wolves, though dire wolves, larger, stronger, more specialized, did not. Horses survived in Eurasia but went extinct in the Americas, their homeland, only to be reintroduced thousands of years later by European colonizers. Camels survived in Asia and Africa but went extinct in North America, where they had evolved. Elephants survived in warm regions but vanished from cold ones, even though their mammoth cousins were specifically adapted to cold. The pattern suggests that survival was not about adaptation, but about distribution, about where species ended up when the extinctions occurred, as if geography mattered more than fitness, as if certain regions were designated as preserves and others as clearing zones, as if the planet was being reorganized, species sorted and allocated to appropriate habitats, redundancies eliminated, ecosystems simplified and balanced for the interglacial period that was beginning. This kind of organization requires planning, foresight, an understanding of ecology deep enough to predict which species would thrive in warming conditions and which would become problematic, which would coexist harmoniously with emerging human civilizations, and which would compete or conflict, which were essential for ecosystem stability and which were expendable. Consider the extinction of large predators. Saber-toothed cats, short-faced bears, dire wolves, American lions, all gone, all removed from the Americas at the end of the Pleistocene, leaving an ecosystem with far fewer large carnivores than it had contained for millions of years. Smaller predators survived, cougars, wolves, regular bears. But the apex predators, the specialists in killing megafauna, were eliminated. This makes sense if the goal was to create space for human expansion. Large predators compete with humans. They threaten livestock, children, settlements. They require vast territories to sustain their populations. An ecosystem dominated by megafauna predators is not hospitable to agricultural civilizations, but an ecosystem with smaller, more manageable predators is. It's dangerous enough to teach humans respect for nature, but not so dangerous that human communities cannot establish themselves. The same logic applies to the megaherbivores. Mammoths and mastodons consumed enormous quantities of vegetation. They shaped entire ecosystems through their feeding, trampling forests, maintaining grasslands, distributing seeds in their dung across hundreds of kilometers. They were ecosystem engineers, as powerful in their ecological effects as any keystone species. But they were also slow to reproduce, vulnerable to overhunting, impossible to domesticate. Remove them, and you remove the competition for vegetation. You remove the ecological engineers that maintain ecosystems in states inhospitable to agriculture. You make room for domesticated cattle, sheep, horses. You allow forests to return in some areas, creating timber resources. You simplify the ecosystem, make it more manageable, more predictable, more suited to support an intelligent species that would need those resources. It's difficult to think this way, to consider extinctions as intentional, as beneficial. It feels wrong, callous, as if dismissing the value of the species that were lost. But if the ice ages themselves were engineered, if the entire Pleistocene was a managed process designed to shape the evolution of intelligence, then the extinctions at its end might have been part of the design. The final step, the clearing away of conditions that were necessary during the ice ages but would be counterproductive in the warm period that followed. The megafauna forced humans to be clever, to cooperate, to develop weapons and strategies and social structures capable of bringing down creatures far larger and stronger than ourselves. They were the crucible in which human intelligence was forged. But once that forging was complete, once humans had developed the cognitive and social capabilities required for civilization, the megafauna were no longer necessary. They became obstacles, and so they were removed. Not by humans alone. We participated, certainly. We hunted. We contributed to the extinction pressure. But the extinctions were too coordinated, too comprehensive, too precisely timed to be purely the result of human activity. Humans were the tool, perhaps, the mechanism, but the selection of which species to hunt, which to ignore, which regions to clear, and which to preserve, that pattern suggests guidance. Suggests that human hunting pressure was itself being directed, consciously or unconsciously, toward specific ecological goals. How would you guide human behavior without humans knowing they were being guided? Through instinct, perhaps. Through preferences shaped by evolution to align with larger purposes. Humans naturally prefer certain prey animals, ones that are large enough to provide substantial meat, slow enough to hunt with primitive weapons, social enough to be predictable. These preferences would drive hunting toward megafauna rather than smaller, faster game, would concentrate extinction pressure on exactly the species that needed to be removed, or through cultural transmission, through stories and traditions and hunting practices that were taught and passed down, that seemed to emerge naturally from human communities but might have been seeded, influenced, shaped by something that understood which species should be targeted and which should be left alone. Oral traditions about which animals are good to hunt and which are sacred. Taboos against killing certain species. Rituals that encourage hunting others. Cultural knowledge that looks like human invention but might be guidance from something older. This is speculation layered upon speculation. There is no evidence of external guidance shaping human hunting behavior. No proof that extinctions followed a designed pattern rather than emerging from the chaos of climate change and human expansion and ecological disruption. The fossil record shows extinctions. It does not show intention, cannot show intention, because fossils preserve only what died, not why it died, not whether its death served a purpose beyond the immediate act of killing. But the pattern exists. The selectivity exists. The correlation between human arrival and extinction exists. But so does the correlation between extinction and the end of the ice ages. And so does the correlation between what went extinct and what would need to be removed to create ecosystems hospitable to human civilization. Too many correlations. Too much pattern, too much precision in what survived and what did not. And if the extinctions were selective, if they served ecological purposes beyond natural selection, then the question becomes, who benefits? Who gains from a world cleared of megafauna, simplified in its ecology, organized to support intelligent life that will soon develop agriculture, cities, technology? Who profits from the removal of ice age specialists and the preservation of species adapted to warmer, more stable conditions? The obvious answer is humanity benefits. We inherited a world that, despite its extinctions, despite the loss of so many magnificent creatures, is remarkably suited to our needs. Ecosystems productive, but not overwhelming. Predators dangerous, but not insurmountable. Prey animals that can be domesticated. Plants that can be cultivated. A planet that seems almost designed to support the development of civilization. Perhaps that is coincidence. Perhaps we simply adapted to the world we found ourselves in, and any species would find its environment seemingly suitable because survival requires fitness to environment. Perhaps the extinctions cleared space that we filled, and now we look back and think how convenient, how fortunate, how perfectly arranged, when really we are simply the species that survived and adapted and sees the world through the lens of our own success. Or perhaps the arrangement was deliberate. Perhaps the world was shaped to suit us. Perhaps humanity is not the accidental beneficiary of ice age extinctions, but the intended result. The reason for the extinctions. The species that the entire Pleistocene was designed to produce and prepare a world for. And if that is true, then the ice ages were not just climate cycles, but a breeding program. Not just glacial advances, but a controlled experiment in evolution. Not just geological processes, but conscious design, executed over millions of years, with the patience of something that thinks in epochs rather than lifetimes, that watches species rise and fall the way a gardener watches seasons change, waiting for the moment when the desired flower finally blooms. There are stories older than writing, passed down through generations in words alone, in the voices of elders speaking to children around fires, in songs and chants and ritual recitations that preserve memory without the need for symbols carved in stone. These oral traditions carry knowledge across centuries, sometimes across millennia. They remember events that happened so long ago that they have been transformed into myth, into allegory, into tales of gods and monsters that bear only passing resemblance to the historical events they encode. But the memory persists, distorted, metaphorical, but persistent. And across the world, in cultures separated by oceans and continents, in traditions that had no contact with each other until modern times, there are myths that remember the same thing. The world became cold. Not gradually, not as part of natural seasonal variation, but suddenly, deliberately, because someone made it so. The Norse myths speak of Fimbulwinter, the great winter that precedes Ragnarok, the end of the world. 3 winters in succession with no summer in between. Snow falling from every direction. Frost and bitter winds. The sun giving no warmth. Brothers fighting brothers as resources fail and society collapses. The world freezing before it burns, before the gods themselves die and the cosmos is reborn. This is usually interpreted as apocalyptic allegory, a metaphor for the end times, for the chaos that precedes renewal. But the details are specific. 3 winters. No summer. Snow from all directions. These are not generic descriptions of cold, but particular details that match what ice core data suggests happened during certain rapid cooling events, like the Younger Dryas, when temperatures plunged within decades and stayed low for a millennium before abruptly warming again. The Norse myths don't just describe the cold. They assign it cause. They say that Fimbulwinter comes because the bonds that hold the cosmos together are weakening, because the gods are losing their power, because something fundamental in the order of the world has broken or been broken. They don't say the cold is natural. They say it's a consequence of divine failure or divine conflict. They say the world is cold because the forces that should keep it warm are no longer functioning. If you translate this from theological language into technological language, it becomes, the system that regulates climate has failed or been shut down. The mechanisms that maintain warmth are no longer operational. The cold is not weather, but the absence of something that was preventing cold. Similar myths appear in other northern traditions. The Sami people of Arctic Scandinavia tell stories of Begolmai, the wind being who brings eternal winter when the balance of the world is disturbed. The Inuit have legends of Nanarlok, the great bear who commanded ice to cover the world when humans forgot the old ways, when they stopped respecting the agreements that had been made with the powers that shape climate. These are not stories about natural climate variation. They are stories about beings, whether called gods or spirits or powers, who control climate deliberately, who can bring ice as punishment, as correction, as response to human behavior, who have agency over temperature, over glaciation, over the fundamental parameters of habitability. And they are not unique to northern cultures, where ice and cold are constant presences and might naturally feature prominently in mythology. Similar stories appear in tropical and temperate regions, places where ice is rare or unknown, where cold is something that comes only in stories, remembered from a time so distant that it seems impossible. The Aboriginal peoples of Australia have oral traditions that speak of times when the land was colder, when snow fell in regions that now see only heat and sun, when the Dreamtime ancestors had to teach people how to survive in conditions that the land was not meant to have. These traditions are difficult to date, but linguistic analysis and correlation with archaeological evidence suggest they may preserve memories from 15,000 years ago or more from the depths of the last ice age, when global temperatures were lower and even Australia experienced cooler, drier conditions. But the Australian myths don't describe the cold as natural. They describe it as wrong, as a deviation from the proper order established in the Dreamtime. And they describe efforts to correct it, to restore warmth, to negotiate with the powers that control such things. They suggest that the cold was not supposed to happen, that it violated the original design of the world. This theme appears across indigenous American traditions as well. The Hopi speak of previous worlds that ended in ice, where the people were forced to migrate underground to survive, where they lived in darkness and cold until the world above warmed again and they could return. The Iroquois have legends of Sky Woman and the creation of the world, but embedded in those legends are references to times when the earth froze, when winter lasted years, when the balance was lost and had to be restored. These are not isolated stories. They are variations on a theme that appears globally. The world was warm, then it became cold, not gradually but suddenly, and the cold was caused by something, by divine anger, by broken agreements, by the failure of systems that should have prevented it. And then there are the flood myths. These are better known, more widely studied. Nearly every culture has them. Stories of a great deluge that covered the world, destroyed civilization, forced survivors to flee to high ground or to build boats. The biblical flood, the Mesopotamian epic of Gilgamesh, the Hindu myth of Manu, the Greek story of Deucalion, the Chinese legend of Gunyu, the Aztec story of the fourth sun ending in water. Science has explanations for flood myths. Rising sea levels at the end of the last ice age would have inundated coastal areas where early civilizations lived. The flooding of the Black Sea Basin. Regional catastrophes like river floods or tsunamis that, to people with limited geographic knowledge, would seem like the whole world drowning. These explanations are reasonable. Floods happen. People remember them. Stories spread. But the myths describe more than local floods. They describe global inundation. They describe waters rising high enough to cover mountains. They describe a world-ending event, not a regional disaster. And they describe it not as natural weather, but as deliberate action, as punishment, as cleansing, as a choice made by gods or powers who decided that the world needed to be reset, that civilization had gone wrong and needed to be washed away. What if the myths are inverted memories? What if the flood stories are not about water rising, but about ice melting? What if they preserve memory not of the Holocene flooding that followed the ice ages, but of the ice ages themselves, remembered backward, as it were, because oral tradition confused the sequence, or because the trauma of the ice melt was more dramatic, more immediately devastating, than the slow advance of glaciers thousands of years earlier? When ice sheets 2 miles thick melt, they release staggering volumes of water. Sea levels rise by hundreds of feet. Coastlines that have been stable for thousands of years are inundated within decades. Entire landscapes disappear. Communities that have existed for generations are forced to migrate inland, to higher ground, carrying with them only what they can save from the rising waters. This is catastrophe. This is trauma deep enough to embed itself in cultural memory for millennia, deep enough to become myth, to be retold and elaborated until it becomes a story about gods and divine anger and the destruction of a wicked world. But if the myths remember the melting, they might also remember what came before: the cold, the ice, the sudden shift from warm to frozen. And perhaps they remember it not as natural, but as engineered, as deliberate, because that's what the ancestors who lived through it believed. Because they saw patterns in how the cold descended, in which regions froze first, in how the ice advanced with what seemed like purpose rather than random spreading. The myths don't use words like geoengineering or climate control. They use words like curse and judgment, and the gods grew angry. But strip away the theological language, and what remains is the same claim. Someone made the world cold. Someone with power over climate. Someone who could alter temperature. Someone who chose to bring ice. And some myths go further. They don't just describe the cold arriving. They describe why it arrived. They say it was because humans had grown too numerous, too proud, too disruptive. They say the world needed to be simplified, populations reduced, civilization reset. They say the ice came not to destroy but to preserve, to put humanity through a crucible that would test us, shape us, make us stronger, or eliminate us if we could not adapt. This narrative appears in Zoroastrian tradition, in the story of Yima, who is warned of coming winter and builds an underground refuge, a vara, to preserve the best of humanity and animals and plants through the long cold. It appears in certain Hindu texts that speak of cycles of yugas, of ages where the world goes through phases of growth and collapse, where each cycle ends in destruction that clears the way for renewal. It appears in Mayan cosmology with its cycles of world ages, each ending in catastrophe, by fire, by flood, by wind, and yes, by cold. These are not primitive misunderstandings of weather. These are sophisticated philosophical frameworks that see climate as managed, as part of a larger system that operates according to rules that include intentionality. That see ice ages not as geological accidents, but as corrections, as necessary destructions that serve longer purposes. Modern science dismisses these frameworks as pre-scientific thinking, as humanity's tendency to anthropomorphize nature, to see agency where there is only mechanism. And perhaps that's correct. Perhaps the myths are simply our ancestors' attempts to make sense of climate events they couldn't explain, to find meaning in disasters that were ultimately random. But what if the myths are more accurate than the science? What if our ancestors were right to see the ice as deliberate, right to believe that climate was being controlled, right to pass down stories warning that the cold could return if certain conditions were met or certain balances disturbed? What if the myths are not memory of the past, but prophecy about the future? Because the myths don't just describe the ice arriving. They describe it returning. They speak in cycles. They say the cold has come before and will come again. They say the world moves through ages of warmth and ages of ice, and that these ages are not random, but patterned, scheduled, part of a cosmic order that humans can observe but not prevent. The Norse myths say that after Ragnarok, After Fimbulwinter and the death of the gods, the world will be reborn green and warm. But the cycle implies continuation. If the world was destroyed and reborn before, it can happen again. Will happen again. The cold will return when the time is right, when the balance tips, when whatever powers govern these transitions decide that another reset is necessary. Indigenous traditions carry similar warnings. Elders speak of signs to watch for: changes in weather patterns, animal behaviors, the positions of stars. They say these signs will tell you when the world is preparing to change again, when the warm time is ending, when the cold is coming back. And perhaps they are right. Perhaps the myths preserve not just memory, but understanding. Perhaps our ancestors knew something we have forgotten, that the ice ages were not accidents of orbital mechanics, but managed events, that they follow rules we no longer recognize, that they will return not because of natural cycles, but because whatever initiated them is still operating, still maintaining the pattern, still waiting for the conditions that trigger the next advance. The oral traditions speak. Across continents, across millennia, they tell the same story in different languages. They say, someone controls the ice. Someone decides when it comes and when it goes. And if that someone decided once to freeze the world, they could decide again. The myths remember what history has forgotten. They preserve what writing never recorded. They whisper across the centuries that the ice was not natural, that the cold was chosen, that somewhere in the deep patterns of climate and time, there is intention. And intention, once established, does not disappear. It waits, watches, maintains its systems. And when the moment comes, when the signs align, when the conditions are right, when the purpose that brought ice before requires ice again, it will act. The ancestors knew this, encoded it in stories that would survive when everything else was buried beneath glaciers, left us warnings wrapped in mythology, preserved in metaphor, waiting for the generation that would finally understand what they were trying to say. That the ice remembers, that the cold is patient, and that what was engineered once might be engineered again when the world requires it, when the balance must be restored, when another reset becomes necessary. And perhaps that time is closer than we imagine. Perhaps the signs the myths describe are already appearing. Perhaps the planet is already preparing for the next transition, the next cycle, the next deliberate descent into cold. There is a clock that no one watches. It doesn't tick in any way we can hear. It doesn't hang on walls or rest on bedside tables. But it runs nonetheless, measuring not seconds or hours, but epochs, not days, but ice ages. And according to its rhythms, the orbital mechanics, the patterns in the geological record, the mathematics of glacial cycles, we are living in borrowed time. The current interglacial period, the warm window we call the Holocene, began 11,700 years ago. The ice retreated. The glaciers melted. Temperatures rose to levels comparable to those before the last ice age. Forests returned to lands that had been tundra. Humans transitioned from nomadic hunting to agriculture, from scattered tribes to settled civilizations. We built cities in the space that ice had cleared. We domesticated plants and animals. We developed writing, mathematics, astronomy. We created everything we think of as human civilization. All of it in a warm period that, statistically, should have ended already. The previous interglacials, the warm breaks between ice ages, lasted between 10 and 15,000 years. Some were shorter. The one before the last ice age lasted only 8,000 years before temperatures dropped again and the glaciers returned. We are now nearly 12,000 years into our current warm period. We are approaching the upper limit of how long interglacials typically last, and yet the ice has not returned. The glaciers remain at the poles, remain in mountains, but do not advance, do not spread. Do not begin the slow reconquest of continents that orbital mechanics suggests should be happening. The Milankovitch cycles are entering a phase that should favor glaciation. Summer sunlight at high northern latitudes is declining. The conditions that trigger ice ages are present, but the trigger has not been pulled. Climate scientists attribute this to several factors. The levels of carbon dioxide in the atmosphere, elevated by human activity, are creating a greenhouse effect strong enough to counteract the orbital cooling. The loss of ice sheets in the last glaciation may have altered ocean circulation in ways that prevent rapid cooling. The configuration of continents, the distribution of land and sea, the presence of mountain ranges that affect atmospheric flow, all of these might be contributing to unusual stability. These explanations are probably correct, probably sufficient. The climate system is complex enough that multiple factors can combine to produce outcomes that seem anomalous, but are actually just the result of complicated interactions we're still learning to model. But there is another possibility, one that emerges not from climate models, but from the patterns we've been tracing through this long meditation. One that becomes visible only when you step back far enough to see the entire span of the Pleistocene, to recognize the regularity that shouldn't exist, to acknowledge the precision that natural systems rarely display. What if the interglacial is lasting longer because something is maintaining it? What if the systems that initiated the ice ages, that controlled their timing, that managed their advances and retreats, are still operating? And what if those systems have decided, for reasons we cannot know, that the current warm period should continue? This is not a comforting thought. It suggests that our climate is not under our control, that the stability we enjoy is not the result of favorable conditions or fortunate timing, but of allowance. Permission. That we live in warmth not because we've earned it or because nature randomly favors us, but because something has chosen to extend the interglacial beyond its normal duration. And if it can be extended, it can also be ended. The mechanisms would still be in place. Whatever systems existed to trigger glaciation before, whether geoengineering infrastructure buried beneath ice, or biological agents designed to alter atmospheric chemistry, or simply the knowledge and capability to nudge climate parameters at critical moments, would still be functional, still waiting, still capable of initiating the next ice age when the decision is made that the time has come. What would that decision depend on? Perhaps on us, on whether humanity has fulfilled whatever purpose the ice ages were designed to cultivate, on whether we have developed the intelligence, the technology, the wisdom to take over the management of climate ourselves, to become the next architects, to inherit the responsibility of maintaining Earth's habitability across the astronomical timescales that threaten it. Or perhaps the decision depends on nothing we do. Perhaps it follows rules we don't understand, patterns that operate on timescales longer than human history. Perhaps the ice will return when certain astronomical conditions align, when the solar system reaches a particular position in its galactic orbit, when cosmic radiation reaches certain thresholds, when factors we haven't discovered yet combine in ways that require another reset. The planet shows signs, not obvious ones, not the dramatic indicators that would appear in news headlines or trigger emergency conferences, but subtle shifts, patterns that emerge when you look at decades of data instead of individual years. Changes that scientists notice and document and discuss in technical papers, but that don't translate easily into public alarm because they're statistical, probabilistic, too complex to summarize in sound bites. Ocean circulation is slowing. The Atlantic meridional overturning circulation, the system of currents that carries warm water north and cold water south, that redistributes heat across the planet, is weakening. Not dramatically, not catastrophically, but measurably, consistently. Over the past several decades, the flow has decreased by approximately 15%. Climate models suggest this is partially due to freshwater from melting Greenland ice diluting the salt content of North Atlantic water, reducing its density, making it less likely to sink and drive the circulation. This is a concern because the last time this circulation weakened significantly was during the Younger Dryas, 12,800 years ago. That event plunged the Northern Hemisphere back into Ice Age conditions for 1,000 years. The mechanism is understood: slow the circulation, and you reduce the heat transport to northern regions. Reduce heat transport, and temperatures drop. Drop temperatures enough, and snow accumulates. Accumulate snow, and ice sheets begin to form. We are not at that threshold yet. The weakening is gradual. The system is resilient, but the trajectory is concerning. And what makes it more concerning is that it's happening during a period of global warming. While the planet as a whole heats up due to greenhouse gases, the North Atlantic is cooling. Ice melt is freshening the water faster than warming can compensate. The two processes, warming and circulation shutdown, are operating simultaneously, pulling climate in opposite directions. This creates instability, unpredictability, the kind of conditions that precede rapid transitions, the kind of setup that, in the geological record, appears right before the climate flips from one state to another. And there are other signs. The jet stream, the river of fast-moving air that circles the northern hemisphere, that separates cold polar air from warmer temperate air, is becoming wavier, more erratic. Instead of flowing in relatively smooth west to east bands, it's developing large meanders, dipping far south in some places and far north in others. This brings Arctic cold to regions that normally don't experience it, brings unusual weather patterns, makes seasons less predictable. This too is precedent in the ice core record. Before rapid cooling events, before the climate transitions that mark the boundaries between warm and cold periods, the atmospheric circulation patterns show increased variability. The system becomes chaotic before it settles into a new stable state. What we're seeing now in the jet stream might be the early stages of that chaos. The planet testing different configurations, preparing for a shift, or it might be nothing. Climate is always variable. The system is always adjusting to changes in forcing, solar output, volcanic activity, orbital parameters, greenhouse gas concentrations. What looks like preparation for a transition might just be normal fluctuation, noise in the data, variation that has no long-term significance. But when you combine the weakening circulation, the erratic jet stream, the orbital parameters entering a phase that favors glaciation, the historical pattern of interglacials lasting 10 to 15,000 years, and the knowledge that our current warm period is already past the median duration, the combination suggests a planet that is, at minimum, positioned for change, that has the conditions in place for a transition, that could, with the right trigger, begin the descent into the next ice age. What would that trigger be? In natural terms, probably nothing dramatic. Just a series of unusually cold summers in northern regions. Snow that falls in winter and doesn't fully melt in summer, each year adding a bit more than the previous year. Slowly, over decades, accumulating into persistent snowfields, into small glaciers, into ice sheets that begin to grow and spread and eventually, over thousands of years, cover continents again. This is the natural progression. The way ice ages begin in the models. Gradual, incremental, barely noticeable at first. But if the ice ages were never natural to begin with, if they were initiated and managed by something that understands climate engineering, then the trigger might be different, might be deliberate, might be a decision made by systems still operating beneath the ice, still monitoring atmospheric conditions, still comparing current parameters to the programmed schedule, still waiting for the moment when intervention is required. And perhaps that moment is approaching. Perhaps the extended interglacial has served its purpose, allowing humanity to develop civilization, technology, science, allowing us to reach a level of capability where we can understand what was done to us, where we can recognize the engineering in the ice ages, where we can potentially take over the maintenance ourselves. Or perhaps we have failed some test. Perhaps we were supposed to have developed certain capabilities by now, supposed to have achieved certain milestones, and our failure means the program proceeds to its next phase. The reset, the return to cold, the clearing of the board so that evolution can try again, can work with different species, different conditions, different possibilities. These are not scientific hypotheses. They cannot be tested, cannot be modeled, cannot be proven or disproven with the tools science has available. They exist in the space between data and interpretation, between what we observe and what we infer, between the patterns we detect and the explanations we construct. But the space is real. The gap between what climate models predict and what actually happens is real. The anomalies in ice cores are real. The structures beneath Greenland are real, even if we don't know what they are. The orbital mechanics that should have triggered the next ice age but haven't are real. And the possibility, however remote, however speculative, that all of this is connected, that the ice ages were designed and the design is still active, that we are living in a managed climate that could be altered again at any moment. That possibility cannot be entirely dismissed. Not with certainty. Not when so much remains unexplained. The planet waits. The ice waits. And we, in our brief warm window, build our civilizations and tell ourselves we understand how the world works, how climate functions, how stable or unstable our future might be. But beneath our feet, beneath the ice that has retreated but not vanished, beneath the oceans and the continents and the layers of rock and time, something may be watching. Something that has been watching for millions of years. Something that initiated the cold once and could initiate it again. Or perhaps nothing watches. Perhaps the ice is just ice. Perhaps the patterns are coincidence. Perhaps we are alone on a planet governed only by physics, by orbital mechanics, by the blind interactions of atmosphere and ocean and ice that produce climate through no intention but their own inherent nature. Either way, the question remains, what if the ice age wasn't natural, but engineered? And beneath that question lies another. What if we are living in the pause before the next activation? In the brief silence between one breath of winter and the next? The glaciers do not speak in words. They speak in motion, in the slow creep of ice down valleys, in the calving of icebergs from their edges, in the meltwater that flows from beneath them, carrying sediment that has been trapped for thousands of years, releasing it back into the world. And if you listen carefully to what that motion says, if you watch the patterns of retreat and advance over decades instead of days, you begin to notice something. The glaciers are not melting randomly. They are not retreating uniformly. Some regions melt faster than others. Some ice sheets thin while others remain stable. The pattern of loss is not what climate models predict. It should be based purely on temperature increases. There is structure in the melting. Organization. As if certain areas are being exposed first. As if the retreat is following a sequence, revealing things in order, allowing access to regions that have been buried longest. Perhaps this is just the natural consequence of geography. Different regions have different bedrock depths, different ice thicknesses, different exposure to warming ocean currents. The uneven melting is simply physics playing out across a heterogeneous landscape. Or perhaps it is intentional. Perhaps whatever maintains the climate is now choosing to withdraw that maintenance, to allow the ice to melt in specific patterns, to reveal what has been hidden, to expose evidence that has been preserved, waiting for the moment when humanity would be ready to find it. Ready or not, because that is the other possibility that haunts the edges of this meditation. That we are not ready. That we were supposed to develop further before the ice released its secrets. That by triggering rapid melting through our own industrial activity, through our own greenhouse gas emissions, we have accelerated a process that was meant to unfold more slowly. We have forced the reveal before we have the wisdom to understand what we're revealing. And if that's true, then the systems that controlled the ice ages might respond, might initiate correction, might decide that humanity has become a threat to the planetary management systems, that we are disrupting patterns that should not be disrupted, that we need to be contained, reduced, reset. The ice would be an effective tool for that. Nothing kills civilizations more thoroughly than glaciation. Nothing erases cities and infrastructure and the accumulated knowledge of millennia more completely than 2 miles of grinding ice. If we need to be reset, if humanity needs to be reduced to small populations that must struggle to survive, that must relearn cooperation and humility and respect for forces beyond their control, ice would accomplish that. And it would happen quickly, not on geological timescales, but on human ones. If the systems that initiated previous ice ages still exist, still function, they would know how to trigger rapid cooling, how to inject the right chemicals into the stratosphere, how to disrupt ocean circulation precisely enough to shut down heat transport, how to use the planet's own feedback mechanisms to amplify a small initial cooling into full glaciation within decades. We would see it beginning, would recognize the signs, would understand, too late, that something had changed, that the pause was ending, that the borrowed time had run out. But perhaps none of this will happen. Perhaps the ice ages really were natural. Perhaps the patterns are coincidence. The anomalies are measurement error. The structures beneath the ice are just geology. Perhaps we live on a random planet that happens to cycle through warm and cold periods due to nothing more than orbital mechanics and atmospheric chemistry. And our current warm period will last as long as physics dictates, no more, no less. Perhaps we are alone. Perhaps consciousness is rare enough that Earth has only produced it once. Perhaps there were no architects, no engineers, no intelligence before us shaping the climate and the evolution of life towards some purpose we cannot fathom. Perhaps, but the question remains. Hovering, unanswerable with the evidence we have, but impossible to dismiss entirely. The question that opened this meditation and now closes it, having traveled through ice and isotopes, through mathematics and mythology, through the geology of buried continents and the chemistry of ancient air. What if the glaciers that buried the world were not summoned by accident, but by design? What if someone, somewhere, once looked at a planet and chose winter? The ice remembers, even if we have forgotten, even if we never knew. It preserves the evidence in layers we have not yet drilled, in structures we have not yet exposed, in patterns we have not yet learned to recognize as patterns. And as you drift towards sleep tonight, as your breathing slows and your thoughts dissolve into the darkness behind closed eyes, perhaps you can feel it. The weight of that question. The possibility that everything we think we know about our world, about our history, about the naturalness of the forces that shaped us, might be incomplete. That beneath the surface of accepted knowledge, there are depths we have not explored, truths we have not uncovered, purposes we have not understood. The planet is old, older than our species, older than our genus, old enough to have held civilizations that rose and fell and left no trace except in the patterns they wove into climate, into evolution, into the deep structure of how Earth works. And if such civilizations existed, if they understood how to engineer ice ages, if they built systems that still operate beneath glaciers and oceans and stone, then we are not the first intelligence this planet has produced. We are inheritors, children of a designed climate, products of engineered winter. And the ice that shaped us has not forgotten its purpose, has not released its hold. It merely waits at the poles, patient as time itself, ready to advance again when the signal comes, when the conditions align, when whatever maintains the pattern decides that another winter is needed. Wherever you are tonight, beneath blankets, beneath roofs, beneath skies that have not seen glaciers for 12,000 years, the ice remembers you, remembers the species it forged in cold and pressure, remembers the intelligence it cultivated through cycles of freeze and thaw. And perhaps, in some way we cannot perceive, it is watching still, waiting to see what we will become, whether we will understand, whether we will take up the responsibility of maintaining what was built, or whether we will need to be shaped again by cold. The question floats like snow, settles like frost, becomes part of the landscape of possibility that we navigate in our search for truth. What if the ice age wasn't natural, but engineered? The answer, if it exists, sleeps beneath Greenland, beneath Antarctica, beneath the weight of glaciers that have not yet fully retreated, preserved in frozen silence, waiting, just as we wait, in our brief warm window, for the planet to decide whether our summer will continue or whether winter is coming home. Sleep well, dream of ice, and remember that some questions are not meant to be answered immediately, but to be carried forward, generation after generation, until the moment arrives when the evidence finally emerges, when the ice finally speaks, when we finally understand what was done to us and why. Until then, the glaciers keep their secrets, and the cold remembers everything we have forgotten, everything we never knew.